Okay. The questions regarding day one can also be taken through the chat box anytime. So with this, Garima ma'am, shall we start for the second day? Over to you.
Good morning, Negi Saab. This is Dr. Amir speaking from NIDM. Negi sir.
Good morning, sir. How are you?
कैसे हैं आप?
Good morning.
How is Roorkee? Nice to see you once again. Chaliye, good. Okay, so shall we start? Garima ji, can you introduce Negi sir to the participants?
Definitely. A very warm welcome to Dr. S.K. Negi. And Dr. S.K. Negi has been working closely with HPSDMA also for the implementation of our schemes, and he has been very resourceful and helpful for the state. And he also happens to be from Himachal, which is a matter of pride for us. Presently, Dr. Negi is working as the Chief Scientist at CSIR CDRI Roorkee, and he's working in the Architecture and Planning Division and has over 20 years of professional experience in his area of expertise, which is related to architecture and planning, also urban and rural planning and tourism development. His educational background includes Bachelor's in Architecture from Punjab University, Chandigarh, and also has his Master's in Urban and Rural Planning from the University of Roorkee, which is now known as IIT Roorkee. He has over 26 research papers, mainly revolving around his area of expertise, and has written several technical reports, which have offered as the template for forming guidelines, basically for use of glass in buildings, industrialized building system for affordable quality housing. With that short and brief introduction, so we would like you to start your presentation. But just before that, if Amir sir has some introductory remarks to share, so over to you, Amir sir.
Thank you, ma'am. I think we have slightly pressure today. We have 3 lectures, so yes, I'm not going for that. But yesterday, what we discussed was amazing, and we are slightly. We started with that basic introduction, then we built on some civil engineering aspects. So today is focusing. Major focus is on local knowledge, whatever is available in our system. So this is the focus of today's thing, and then last session is for retrofitting. So not only Himachal Pradesh we are focusing Uttarakhand as well. So the best practices in rural housing from Uttarakhand, traditional knowledge, local knowledge, use of local material, all these things are being discussed in the first 2 lectures, and then third lecture is on retrofitting techniques. So this is the limitation of 3 days program, but if we feel the need, we may have another program, a slightly better version of this one. So where we can discuss all these things in detail. So this is in brief from my side, and I'll give the podium to or screen to Negi Saab.
Over to you, sir.
Okay, thank you, Amir Saab. Hello.
Please continue.
Okay, I'll continue. Okay, just I'll share my presentation first. My slides are visible?
हाँ,
visible है ना, ये दिख रहा है?
हाँ, please go ahead.
Yeah, good morning to all. Yeah, good morning to all. I will session. Actually, I'll be talking about the mainstreaming of construction practices in hilly regions. Basically, जो हमारा construction system है, particularly since this topic is on safe construction practices in rural areas. So my focus will be on basic construction system which we have for last so many years, in particularly in Himachal, and in between, if you have any questions, you can ask, interrupt in between. I don't have any problem. But before I start my main presentation, I'll want to give you some brief about the introduction of this topic. As per 2011 census, अगर आप देखेंगे तो अर्बन पॉपुलेशन जो है ऑलमोस्ट 10 10.0 एरिया 10%। अगर टोटल पॉपुलेशन तो हमारा 70 लाख से ज्यादा है, 7 लाख के करीब हमारे उसमें रहते हैं। और दूसरा, अगर आप इन टर्म्स ऑफ ज्योग्राफिकल लैंड एरिया, उसमें अगर आप देखें 3.65% जो ज्योग्राफिकल लैंड है वो अर्बन एरियाज में यूज होता है, जो अर्बन एरियाज में, या मतलब कह लीजिए। और ये पॉपुलेशन अगर आप देखें तो स्टेट के पॉपुलेशन के हिसाब से देयर इज अ ह्यूज प्रेशर ऑन दीज अर्बन सेंटर्स। और दूसरा, जो भी हमारे को कंस्ट्रक्शन आगे फ्यूचर में करना है, तो हमारे को अगर जो हमारे एग्जिस्टिंग कंस्ट्रक्शन सिस्टम्स थे या जो चल रहे हैं, उसमें हमारे को क्या चीज बेटर करना है, क्योंकि हमारा पूरा स्टेट जोन 4 और जोन 5 में आता है। क्योंकि आई वाज जस्ट गोइंग थ्रू दी रंधावा जी का प्रेजेंटेशन, डॉक्टर अजय चौरसिया जी का, खान साहब का जो पहला दिन का प्रेजेंटेशन देख रहा था, तो ये सारी चीजें उसमें कवर किया गया था। तो अगर जो डेवलपमेंट है हमारा हिल्स का, अगर हम स्पेशल अगर हम हमारे टाउन्स या सिटीज में देखें तो बहुत ज्यादा प्रेशर है। क्योंकि जो प्रेशर हमारा सिटीज या वो ले नहीं सकते, क्योंकि हमारा जो सिस्टम है, क्योंकि एक तो हमारा हिमालयन माउंटेन्स, यंग माउंटेन्स में आता है, एंड अनदर इज लाइक वी हैव अ वेरी फर्जाइल इकोसिस्टम बिकॉज माउंटेन्स आर वेरी यंग, और उस पर अननेसेसरी प्रेशर डालना बहुत ही गलत है। इसलिए हमारे को ये करना है कि हमारे को वट एवर द पॉपुलेशन वी हैव इन द रूरल, almost 90% population in Himachal lives in rural area, so we have to strengthen that area. दूसरा, ये जो भी हिल्स हैं, वी हैव वेरी, मतलब वहाँ सीनिक ब्यूटीज बहुत ज्यादा है ना, इस वजह लोगों का आना और प्रेशर बहुत रहता है, इसलिए डेवलपमेंट वहाँ चलते रहते हैं। तो वो डेवलपमेंट हम इस प्रकार से करें, वो एक तो सस्टेनेबल, या जो भी डेवलपमेंट हम कर रहे हैं, इन अदर वर्ड्स, इट शुड नॉट बी अफेक्टेड बाय द एनवायरमेंट, और वी शुड नॉट मेक टाइप ऑफ स्ट्रक्चर जो एनवायरमेंट में नेगेटिव इंपैक्ट पड़े। अगर उन चीजों को हम लेके करेंगे तो वी विल बी डूइंग बेटर दिस थिंग, फ्यूचर डेवलपमेंट ऑफ आवर कंट्री, आवर स्टेट। और दूसरा जो है, जो पॉपुलेशन डेंसिटी है जो हमारा स्टेट्स में है, उससे भी इफेक्ट हो जाता है कि जहाँ हमारा सेटलमेंट है वहां पर कई बार हमारा क्या होता है कि बहुत बड़े बड़े प्रोजेक्ट्स आ जाते हैं, बड़े प्रोजेक्ट्स आ जाते हैं। हम बेसिकली वहां का ज्योग्राफी या उसके बिना उसको कंसिडरेशन, मेन क्या होता है कि एक तो लैंडस्लाइड्स है, सॉइल इरोजन है, फ्लड है, सारे अर्थक्वेक तो है ही, मतलब ये डिजास्टर्स बहुत ज्यादा हमारे स्टेट में है। तो अगर अभी आप देखा जाए तो मैं जैसे बोल रहा था मेरे फर्स्ट स्लाइड में कि हमारा जो है ऑलमोस्ट जो है 3 कुछ % जो एरिया है उस पे उस एरियाज में यूज हो रहा है। देखिए अगर इस टाइप का अगर लोग फोकस नहीं करें रूरल एरिया में बनने शुरू, तो हमारे को रूरल एरिया डेवलपमेंट कर रहे हैं, वहां का हमारे को इन्वॉल्व करना पड़ेगा, प्रोवाइड करना पड़ेगा। दूसरा, हमारे को वहां के जो ट्रेडिशंस एंड वैल्यूज है या कंस्ट्रक्शन सिस्टम्स है उसको हमारे को फॉलो करके जो भी ओवरऑल डेवलपमेंट है उसको सस्टेनेबल बनाना पड़ेगा। तो एक्चुअली अगर हम हिल्स के रिस्पेक्ट में अगर सस्टेनेबल डेवलपमेंट की बात करते हैं और सस्टेनेबल और डेवलपमेंट का सस्टेनेबल जनरेशन।
नेगी साहब आपकी आवाज कट रही है, अगर थोड़ी देर के लिए अपना कैमरा ऑफ कर देंगे तो हो सकता है। जी
वो बेसिक इसमें क्या
Negi sir,
हेलो वो
sorry to
इम्पोर्टेंट है
interrupt
तो
you, sir. Can you hear us?
इकोनॉमिक
Negi sir,
हेलो
can you hear us?
करना पड़ेगा
Sir, sir, there is I think a lack of network issues, and I think we cannot. Sir,
हेलो
we
आई एम
cannot
नॉट
hear
ऑडिबल
you. Sir, we cannot hear you. Yes, sir. So kindly, sir,
अच्छा
kindly
देयर इज
just
ओके
stop your video,
just
and then
bear
we
with
can
me
probably
for
go with just the
1 minute.
audio
I
line.
will just check it. I think there is some problem. 1 second.
Okay, sir. Okay, sir. So meanwhile, sir comes just checking his connectivity. I request all the participants to raise your questions and
Audio,
queries through chat backs for the technical sessions.
audio, audio.
Yes, sir.
Now it's all. Yeah. Hello. Karima
Yes,
ma'am.
sir. Yes, sir. Can
I'm audible.
Yes,
Now.
sir. Also, your voice is still breaking up.
Hello.
So we suggest if you could
Still
just.
breaking up.
Yes, sir.
Hello. ये नेट का
आवाज थोड़ी ब्रेक हो रही है. अगर आप अपनी वीडियो और स्विच ऑफ कर देंगे तो मतलब वो ऑडियो स्ट्रीमिंग में बेटर आई थिंक क्वालिटी आएगी.
एक मिनट ऑडियो वीडियो को बंद कर दो. हेलो.
हाँ जी सर.
इधर खोलो. 1 second. इसमें बॉक्स आ नहीं रहा है ना. दैट इज अ प्रॉब्लम. इट्स नॉट. वीडियो पे स्लाइड शो.
I think there are some issues with Negi sir.
या
हाँ, Negi sir, please continue.
हाँ डॉक्टर आमिर खान जी.
जी सर. हाँ,
Now
अभी
it is
audible.
audible. ठीक है. Okay, now I'll start. I think there's some this there. यहीं पर. ऊपर ये ऊपर ही हटा दो. Yeah, now it is all right.
Yes, sir. It is
Hello.
all right. Please continue.
Yes, sir. Yes, sir.
Okay. Yeah, I was talking about this how to do the sustainable development of the entire state. उसमें I was talking about like first we have to start with the complete state का हमारे को plan करना पड़ेगा. उसके बाद we have to go reverse like then sub-regional like district level or then at a local level. Until or unless we should have the proper this complete development plan of the entire state, थोड़ा सा डेवलपमेंट करना मुश्किल हो जाएगा क्योंकि हमारे को क्योंकि when we are talking about the safe construction practices for the entire rural India, particularly like state of Himachal और जो उत्तराखंड है, जो भी जितने भी हिली स्टेट्स हैं, वहाँ मैक्सिमम पॉपुलेशन हमारा अभी भी रूरल में रह रहा है. तो दिस इज एक्चुअली टॉपिक इज वेरी गुड और हमारे मतलब स्टेट के लिए भी अच्छा है. दूसरा मेरा जो इम्पोर्टेंट कंसर्न है इस टॉपिक से रिलेटेड, जो हमारा पुराना जो क्लाइमेट कॉन्शियस आर्किटेक्चर होता था, इट्स परहैप्स द ओल्डेस्ट टेक्निक ऑफ सस्टेनेबल डेवलपमेंट इन हिली एरियाज. वो लोग इतने एजुकेटेड थे कि उनको ये पता था कि किस टाइप का कंस्ट्रक्शन हमारे को करना है सो दैट इट विल रेजिस्ट ऑल द डिजास्टर. मतलब कोई भी डिजास्टर आता था, कई सारे स्ट्रक्चर्स ऐसे हैं जो पुराने कंस्ट्रक्शन सिस्टम से बने हुए हैं, स्टिल दे आर स्टैंडिंग. कई सारे अर्थक्वेक्स ले लिए उन्होंने, कई सालों से वो खड़े हैं. दैट आई विल बी टॉकिंग इन माय फ्यूचर स्लाइड्स. और दूसरा हमारे को जो भी हम करें, क्योंकि जो मॉडर्न बिल्डिंग्स हमारे जो अब आ रहे हैं, वो अगर आप प्रेजेंट सिनेरियो में देखें, अनफॉर्चुनेटली दे आर लाइक व्हाट वी आर डूइंग इन प्लेन्स. उसमें कोई ज्यादा डिफरेंस नहीं है क्योंकि हिल्स में कई सारी चीजें हैं. दैट आई विल बी डिस्कसिंग इन माय फ्यूचर स्लाइड्स. क्योंकि आपका वहाँ का वेदर है, वहाँ किस टाइप की टोपोग्राफी है, कई सारी चीजें हैं जो एक बिल्डिंग या कोई भी स्ट्रक्चर हम बना रहे हैं वो उन चीजों से गहन होता है. परंतु हमारे जो भी आर्किटेक्ट्स फ्रेंड है या जो भी इंजीनियर्स है, अभी जो हमारा जो कंस्ट्रक्शन प्रैक्टिसेस है जो एग्जिस्टिंग है या अब आने वाला है, उसमें वी डोंट बॉदर अबाउट द बेसिक टोपोग्राफी और जो वहाँ का लोकल क्लाइमेट, उन चीजों को हम नहीं करते हैं, इसलिए प्रॉब्लम आ रहा है. तो बिफोर आई गो टू द ट्रेडिशनल कंस्ट्रक्शन सिस्टम्स जो हमारा है, ये सब कुछ डिफिकल्टीज हैं जो हिल्स में है. मोस्ट ऑफ द जो हमारे पार्टिसिपेंट्स हैं, दे आर इंजीनियर्स एंड आर्किटेक्ट्स एंड दे आर वर्किंग इन डिफरेंट ऑर्गेनाइजेशंस. उनको सारी चीजें पता है. फिर भी मैं एक जस्ट आपको आइडिया दे दूंगा कि ये इन डिफिकल्टीज से हमारे को क्या क्या प्रॉब्लम्स आ रही हैं और हमारे को क्या करना चाहिए. एक तो हिल्स में डिफिकल्टी ऑफ गेटिंग स्टेबल साइट एंड ओरिएंटेशन इन हिल स्लोप्स सबसे बड़ा प्रॉब्लम है. दूसरा सॉइल इरोजन है, लैंडस्लाइड्स है, ये भी बहुत प्रॉब्लम है. और जो ट्रेडिशनल कंस्ट्रक्शन टेक्नोलॉजीज है वो इसलिए अफेक्टेड है क्योंकि अवेलेबिलिटी ऑफ वुड बहुत प्रॉब्लम है. और दूसरा हमारे पास क्राफ्ट्समैन भी नहीं है, मेसन्स भी नहीं है जो उस पुराने कंस्ट्रक्शन को अब कर पाए. तीसरा ये है क्योंकि हमारा टेरेन इस टाइप का है, जो साइट में जो इंफ्रास्ट्रक्चर डेवलपमेंट है वो बहुत हमारे लिए महंगा पड़ता है. तीसरा कनेक्टिविटी हमारा एज कंपेयर टू अर्बन एरियाज हमारा पुअर है क्योंकि अभी प्रॉपर रोड्स नहीं है, रोड्स हैं तो भी पक्के नहीं है, हेल्थ फैसिलिटीज नहीं है, वाटर सप्लाई, इलेक्ट्रिसिटी, कई सारे सैनिटेशंस तो खैर अब इंडिविजुअल का है, मतलब जो सीवर लाइंस वगैरह अभी नहीं है रूरल एरियाज में, कहीं भी नहीं है. तो दूसरा ये बिकॉज वी डोंट हैव द प्रॉपर रोड्स, तो ट्रांसपोर्टेशन ऑफ बिल्डिंग मटेरियल्स फ्रॉम दिस अर्बन एरियाज या जो भी है प्लेन से हमारा जाता है वो भी प्रॉब्लम है. और जो मेन प्रॉब्लम है क्योंकि रूरल एरियाज में वी डोंट हैव इंजीनियर्स एंड आर्किटेक्ट्स, तो स्पेस यूटिलाइजेशन जो एक बहुत इंपॉर्टेंट है कॉस्ट के टर्म्स में. जब हम रूरल की बात करते हैं तो कॉस्ट बहुत इंपॉर्टेंट फैक्टर हो जाता है. तो ये हमारा स्पेस यूटिलाइजेशन हम अननेसेसरी बहुत बड़े बड़े जगह यूज कर लेते हैं जिसका यूज भी नहीं होता और कॉस्ट हमारा बढ़ जाता है. और तीसरा मैक्सिमम मेजॉरिटी ऑफ द पॉपुलेशन रूरल एरिया इज रिलेटेड टू वो जो इनकम का सोर्स है उनका आइदर एग्रीकल्चर और इट्स एलाइड एक्टिविटी. और मेन है माइग्रेशन ऑफ एजुकेटेड पीपल फ्रॉम रूरल टू अर्बन एरियाज. ये इंपॉर्टेंट है. ये माइग्रेशन अगर हमारा फैसिलिटीज हम हेल्थ फैसिलिटीज, एजुकेशन फैसिलिटीज हम अगर रूरल एरियाज में हम प्रोवाइड करें तो हमारे लोगों का माइग्रेशन जो अर्बन एरियाज में, मैंने फर्स्ट स्लाइड में कहा था कि इतना मतलब कम एरिया में इतने सारे लोग आ रहे हैं, तो ये प्रॉब्लम हमारा कुछ सॉर्ट आउट हो जाएगा। तो मैं थोड़ा सा ये बताऊंगा हम कर रहे हैं इंडिजिनस कंस्ट्रक्शन या जो हमारा कंस्ट्रक्शन प्रैक्टिसेस है वो क्या है। बेसिकली जो ड्वेलिंग या स्ट्रक्चर हम बनाते हैं उस पर्टिकुलर एरिया में, वो जो है लोकल क्लाइमेट और रीजन स्पेसिफिक है। मतलब हिमाचल में क्या, पूरे हिंदुस्तान में कहीं भी जाओ आप, ये चीजें मैटर करता है और इसी हिसाब से वहां स्ट्रक्चर्स बनते हैं। तो जो पुराने स्ट्रक्चर्स बनते हैं, परंतु हम अब जो स्ट्रक्चर्स बना रहे हैं वो सारी चीजें हम ध्यान में नहीं देते। जैसे प्लेन में बन रहा है हम उसी हिसाब से हम काम कर रहे हैं। ये कुछ एग्जांपल्स हैं, आप देख लीजिए। ये हिडिंबा टेम्पल है, ये 1500 में बना हुआ है। उसके बाद ये कुछ स्ट्रक्चर्स उधर कुल्लू साइड के हैं और ये कुछ मॉडर्न है। मॉडर्न में जो कंस्ट्रक्शन प्रैक्टिसेस अब हो रहा है, जो अभी जो हम काटीकनी स्टाइल या काटकोनी बोलते हैं, उत्तराखंड में काटकोनी बोलते हैं, ये जो स्टाइल है अब यूज हो रहा है। कुछ एरिया है सिर्फ कुल्लू में, वो भी नगर कुछ विलेजेस में, या डिस्ट्रिक्ट किन्नौर के कुछ एरियाज में अभी स्टिल दिस कंस्ट्रक्शन प्रैक्टिस इज वर्किंग एंड इट इज परफॉर्मिंग वेरी वेल। परंतु वहाँ जैसे मैंने बताया कि लकड़ी या ये सारी चीजें प्रॉब्लम है, तो इसलिए ये इतना इफेक्टिवली नहीं यूज कर पा रहे हैं। जो अभी तक हमने जो कुछ स्टडी किया था हिमाचल उत्तराखंड में, तो हिल्स में जो भी सेटलमेंट है या जो बिल्ट फॉर्म है हमारा, वो इन फैक्टर्स जो इन्फ्लुएंस करते हैं, दैट इज टोपोग्राफी, क्लाइमेट, मटेरियल रिसोर्स, है ना, और जो लाइफस्टाइल है लोगों का, वो किस तरह से सोते हैं, कैसे खाना खाते हैं, बैठ के खाते हैं, वो मतलब वहाँ का क्लाइमेट जो शुरू में बताया था। फिर वहाँ कंस्ट्रक्शन टेक्नोलॉजीज क्या है, कल्चर और ट्रेडिशंस, वो भी बहुत मतलब एरिया टू एरिया वेरी करता है। इसलिए जो हमारा बेसिक आर्किटेक्चर है या बेसिक स्ट्रक्चर का डिजाइन है वो भी चेंज होता जाता है पूरे हिमाचल में। तो अगर हम ये देखें, तो अगर टोपोग्राफी में देखें, टोटल जो लेंथ है हिमालयस का ऑलमोस्ट 25,000 किलोमीटर, 2500 किलोमीटर है फ्रॉम ईस्ट टू वेस्ट। और जो हैबिटेबल एरिया है 4000 स्क्वायर मीटर से, 4000 मीटर से ऊपर वो पॉसिबल नहीं होता। जो भी लोग रहते हैं 4000 मीटर से नीचे ही रहते हैं। द वेरिएशन इन क्लाइमेटिक कंडीशंस इन हिमाचल वेरीज ड्यू टू वेरिएशन इन अल्टीट्यूड। तो आप ये देख लीजिए, जो कांगड़ा है, ऊना है, ये लो अल्टीट्यूड पे है, वहाँ ये गर्म एरिया है। वहाँ जो कंस्ट्रक्शन सिस्टम में या कंस्ट्रक्शन टेक्नोलॉजीज में आगे डिस्कस करूंगा वो डिफरेंट है। तो आप थोड़ा सा ऊपर चले जाइए, आप जैसे मंडी है या आप कुल्लू वाला एरिया या शिमला का एरिया आ जाइए, वहाँ स्लाइटली डिफरेंट है। जब आप किन्नौर, लाहौल स्पीति और चंबा का कुछ अपर एरियाज है, वहाँ पर इट इज एंटायरली डिफरेंट, क्योंकि जो क्लाइमेट है वो काफी सारी चीजें हमारा गवर्न करता है। परंतु अब जो प्रेजेंट कंस्ट्रक्शन सिस्टम्स को अगर अपने रूरल एरियाज को सेव करना है, तो हमारे को वापस उन सिस्टम्स को फॉलो करना पड़ेगा विथ द प्रेजेंट न्यू कंस्ट्रक्शन सिस्टम। कैसे मर्ज करना है वो हमारे लिए इंपॉर्टेंट है। ये आप लोगों को पता ही है कि मोर देन 64% हमारा जो रूरल एरियाज में है वो फॉरेस्ट एरिया है। और जो प्रिंसिपल बिल्डिंग मटेरियल्स हैं वहां पर, इट इज आइदर वुड, स्टोन और स्लेट। ये सारी चीजें पूरे हिमाचल में यूज होता है, परंतु यूज करने का तरीका डिफरेंट है। वो मैं आगे डिस्कस करूंगा कैसे हम डिस्कस करते हैं। अगर आप ये देखें, मतलब अगर पूरा ओवरऑल सेटलमेंट अगर पैटर्न हिमाचल में देखेंगे ना, जो नेचुरल प्रोफाइल है लैंड का, उसको बड़े हमारे पूर्वजों ने बहुत अच्छी तरीके से यूज किया हुआ है। मतलब अलोंग द कंट्री सारा डेवलपमेंट होता है। इसमें जो टेम्पल या जो भी आपका मेन वो होता है वो फोकस एरिया होता है, उसके चारों तरफ बड़ा सा ग्राउंड होता है। तो पूरे गांव में जो भी एक्टिविटीज, फेस्टिवल या रिलीजियस गैदरिंग्स होता है वही होता है। बाकी जगह एक्चुअली दे कैन नॉट अफोर्ड टू क्रिएट अ बिग स्पेसेस। तो वहाँ ये जनरली ये करते हैं कि जहाँ पर फ्लैट लैंड हो या मेन इंपॉर्टेंट लैंड हो, वहीं पर ये सारी चीजें बनाया जाता है। आप ये पिक्चर देख लीजिए, इसमें ऐसा लगता है कि पूरा जो डेवलपमेंट हो रहा है, मतलब इट इज एज पर द रिक्वायरमेंट ऑफ द नेचर। ऐसा कुछ भी नहीं लगता है कि क्यों अलग से आ रहा है या कोई मल्टी स्टोरी आ रहा है। तो अगर मल्टी स्टोरी कोई चीजें हैं तो ये सिर्फ हमारे कोई या तो किला होगा या कोई फोर्ट होगा या कोई टेम्पल होगा, तो उसकी इंपॉर्टेंस अलग से आर्किटेक्चरली उन्होंने दिया हुआ है। उसमें सारे प्रोविजंस उन्होंने, जो अर्थक्वेक रेजिस्टेंट होना चाहिए या विंड रेजिस्टेंट होना चाहिए, आपका क्लाउड बर्स्ट वगैरह, ये सारी चीजें ये पूरा कैटर करता है, अवेयर थे। अब ये दूसरा एग्जांपल देख लीजिए, इसमें भी देखो ये जो प्राइम लोकेशन है जो वो ऊपर है, बाकी पूरा सेटलमेंट इट इज ऑल अलोंग द कंट्रोल एंड फेसिंग टुवर्ड्स द ईस्ट, क्योंकि ओरिएंटेशन पहाड़ों में सबसे ज्यादा इंपॉर्टेंट है कि नेचुरल लाइट जो घर के अंदर लेके, क्योंकि हार्श क्लाइमेट है तो लाइटिंग बहुत इंपॉर्टेंट रोल प्ले करता है। और ये आप पिक्चर देख लीजिए, इसमें सारी टेक्नोलॉजीज मॉडर्न भी यूज किया हुआ है, इसमें पूरा लाइट वेंटिलेशंस है ना, डिस्टेंस बिटवीन टू बिल्डिंग, वो सारी चीजें प्रॉपरली करके किया गया हुआ है। तो नाउ कमिंग टू दी जो कंस्ट्रक्शन टेक्निक्स है पूरे हिमाचल में हम कौन कौन से यूज करते हैं। एक तो काथकनी कंस्ट्रक्शन है, ये किन्नौर में, कुल्लू, मंडी डिस्ट्रिक्ट है ना, शिमला, सोलन, ये जो अपर रीजन्स में है, यहाँ पर ये कंस्ट्रक्शन सिस्टम है, ये इस टाइप के मकान बनते हैं। दूसरा गज्जीवाल है, गज्जीवाल कंस्ट्रक्शन ये एक्चुअली बेसिकली ज्यादा वहाँ JNK में ज्यादा चलता था। जब ब्रिटिशर्स इंडिया में आए तो उसके बाद कुछ शिमला में, कांगड़ा में, चंबा में और कई एरियाज में ये कंस्ट्रक्शन प्रैक्टिसेस भी हमारा चल रहा है एंड इट इज वेरी गुड। मतलब आपका जहाँ वॉल थिकनेसेस कम करना है कई सारे चीजों में। और दूसरा है ड्राई स्टोन कंस्ट्रक्शन, ये कांगड़ा, किन्नौर और अगर आप ओवरऑल डेवलपमेंट देखें जो वहाँ जो रूरल एरियाज में जो लोग रहते हैं, यूजुअली यू विल फाइंड 2 to 3 स्टोरीड हाउसेस, मतलब हाउस जो है किसी का 3 स्टोरी से ऊपर नहीं है, बहुत रेयर है। वैसे तो G+1 ही है। तो लोअर फ्लोर जनरली वो कैटल अपने वो जो कैटल्स होंगे या मतलब स्टोरेज के लिए यूज करते हैं, अपर फ्लोर्स में दे यूज फॉर देयर अपने रहने के लिए यूज करते हैं। तो इसमें जैसे मड है, मड कंस्ट्रक्शन भी है, मड कंस्ट्रक्शन में ये G+1, G+2, G+3 तक भी गए हुए हैं। तो ये पर्टिकुलरली लाहौल स्पीति और किन्नौर का कुछ अपर एरियाज है जहां पर रेनफॉल बहुत कम है, वहां डायरेक्ट स्नो पड़ता है, तो वहां रेन नहीं है, तो इसलिए ये, और जो वहां पर स्टोन्स भी कम है, तो मड इजीली अवेलेबल है, तो इसीलिए वो फ्लैट रूफ्स और ये मड वॉल्स यूज कर सकते हैं। क्योंकि बहुत हार्श क्लाइमेट है, क्योंकि मिट्टी सबसे बेटर वो है, थर्मल इंसुलेशन मिट्टी के दीवारों में से बढ़िया किसी का नहीं है, इसलिए मड वॉल्स वहाँ क्लाइमेटिक रिक्वायरमेंट के हिसाब से लोगों ने यूज किया हुआ है। अब मैं जो टिपिकल कंस्ट्रक्शन सिस्टम जो
Sorry to interrupt, sir.
काथकनी, हेलो,
Yes, sir. Sorry to interrupt, sir, but we need to be just a little bit faster, just for the reminder, sir.
I will finish in 10 minutes. How much time I have?
Sir, we are still already exceeding,
Hello?
but sir, maybe 6 minutes, sir.
5 minutes I will come. I will conclude.
Okay.
Negi sir,
Thank
take
you
your
so much.
time, but try to be slightly faster. That's all. Thank you.
That's all, sir.
हाँ,
Take your
okay.
time.
इसमें जो ओके जो काथकनी स्टाइल जो कंस्ट्रक्शन है, इसमें जो इंपॉर्टेंट फीचर्स हैं, एक तो स्लेट रूफ है, उसके चारों तरफ वरांडास हैं, देन वॉलिंग सिस्टम बहुत ज्यादा इंपॉर्टेंट है। इसमें आपके बीच में जो है वुडन लॉक्स होते हैं, वुडन लॉक्स को चारा पूरा फ्रेम बनाया जाता है इनफिल्ड विथ ड्राई स्टोन्स, वो उसका डिटेलिंग मैं आपको बताऊंगा आगे। तो इसमें ये प्रोजेक्शंस वगैरह क्या से करते हैं, क्या करते हैं, ये पूरा अगर आप इसके आर्किटेक्चर या स्ट्रक्चर इंजीनियरिंग को आप अगर सिस्टमेटिकली आप देखोगे तो दे वर डूइंग परफेक्टली ऑल राइट। क्योंकि हमने इसका हिमाचल और उत्तराखंड और JNK का स्टडी किया था, तो ये पाया कि अगर साइंटिफिकली भी आप इसको एनालिसिस करोगे तो मतलब इट इज परफेक्टली ऑल राइट। तो इनमें जो डिफरेंस है, जो अगर ट्रेडिशनल जो बिल्डिंग्स जो बनी हुई है, जो अगर टेम्पल्स या ये आपके जो फोर्ट्स बने हुए हैं या किला जो बोलते हैं हम उनको, या जो रेजिडेंसीज में है, बाकी सब कुछ सेम है रेजिडेंसीज, इसमें सिर्फ प्रोपोर्शंस में डिफरेंस है, मतलब वो साइज जो या उसका उसमें डिफरेंस है। और दूसरा जो डिफरेंस है, जो टॉल स्ट्रक्चर्स जो आपके जो फोर्ट्स हैं, डिफरेंट जो स्ट्रक्चर्स हैं, मतलब टेम्पल्स हैं और रेजिडेंसीज में, फाउंडेशन अगर रेजिडेंसीज में हमने पाया कि ऑलमोस्ट देयर इज नो फाउंडेशन, अगर किसी में है तो मुश्किल से 1 फीट है, नहीं तो नहीं है। और जो दूसरी स्ट्रक्चर्स हैं उसमें प्रॉपर लोड्स डिस्ट्रीब्यूशन, फाउंडेशंस और हाई प्लिंथ है। प्लिंथ जो है 1 से 1.5 मीटर ऊपर लिया हुआ है। और दूसरा ये आप ये स्लाइड्स को देखेंगे तो आपको पूरा फेयरली आइडिया मिल जाएगा, क्योंकि ये जो कंस्ट्रक्शन है मतलब अर्थक्वेक रेजिस्टेंट कैसा है। अगर ये कॉर्नर्स में देखेंगे ना, ये एक के ऊपर दूसरा जाता है, इसके कनेक्शन डिटेल्स में आगे बताऊंगा, और हर चीज को प्रॉपरली डिजाइन किया हुआ है। अब क्योंकि इसमें क्या है, ये जो वुडन लॉग्स है हॉरिजॉन्टल आ रहे हैं और ये इधर को जा रहा है, ये इनका कनेक्शन है, ये वुडन नेल्स से किया हुआ है। इसमें दूसरा जो आपका जो दूसरा कील, हम जो नॉर्मल कील लगाते हैं वो नहीं है, जो स्टील का कील लगाते हैं वो नहीं है, क्योंकि अर्थक्वेक में ये जो है ना इसको फ्लेक्सिबिलिटी देती है। ये सारी चीजें इन्होंने बहुत पहले। और दूसरा इसमें एक ये मुसाबी करके ये दो वुडन लॉग्स को जोड़ता है, ये भी दो उसमें वो करते हैं, वो बसोले से चैम्बर वो करके इसमें कमर से लगा देते हैं, ये भी फ्लेक्सिबल रहता है। तो ये आपको ये देख लीजिए। इसमें तीसरा जो इम्पोर्टेंट है, जो अच्छे बिल्डिंग्स हैं उनमें ये कॉर्नर को प्रोटेक्ट करने के लिए कॉर्नर स्टोन का डिजाइन किया हुआ है। तो ये मैं ज्यादा डिटेल में नहीं जाऊंगा। और ये आप देख सकते हैं, ये ड्राई स्टोन्स जो है विदाउट एनी मोटर है। तो अर्थक्वेक के टाइम में या कोई भी डिजास्टर होता है, जब बिल्डिंग शेक करता है तो ये पूरा लिबर्टी देता है आपको पूरे स्ट्रक्चर्स को। और दूसरा इसके जो है वुडन नेल्स से कनेक्टेड है ये, तो ये फ्लेक्सिबल दे रहा है। और ये जो दो लॉग्स को जोड़ रहा है ये मुसाबी, ये बहुत इंपॉर्टेंट है। ये भी कोई नेलिंग नहीं किया हुआ है, सिर्फ उसको हथौड़े से मार के जो लगाया हुआ है, ठोका हुआ है। तो ये पूरा स्ट्रक्चर को मूव करने के लिए लिबर्टी देता है। जब अर्थक्वेक हो जाता है तो उसके बाद ये अपने ओरिजिनल पोजीशन में आ जाता है। और जैसे हम कोर्स में आपको पिछले लेक्चर्स में भी या आने वाले लेक्चर्स में भी बताएंगे कि अर्थक्वेक कोर्स के हिसाब से हमारे को स्ट्रक्चर्स कैसे डिजाइन करने हैं, कि हमारा पूरा इंटायर हिमाचल जोन 4 और जोन 5 में आता है, मैंने शुरू में कहा था। तो इसमें हम जैसे बोलते हैं कि आपको प्लिंथ बैंड होता है, सिल बैंड देना चाहिए, और विंडोज या ओपनिंग्स के दोनों तरफ भी बैंड देना चाहिए, फिर रूफ बैंड देना चाहिए। तो ये सारी बेसिक चीजें आपको इन स्ट्रक्चर्स में मिल जाएगा। तो इसीलिए ये स्ट्रक्चर्स कई साल से खड़े हैं। और ये जो लोग बड़े वाइजली कैसे स्टोरेज स्पेस बनाते हैं, ये दिस इज द एग्जांपल। ये ड्यूरिंग कंस्ट्रक्शन है, अदर वो है आफ्टर कंस्ट्रक्शन है। तो दूसरा जो है, क्योंकि जो हमारा जो आपको शुरू में बताया था, इसमें तो 80% ही लिखा हुआ है मैंने, वैसे 90% के करीब है। तो ये जो बेसिक आर्किटेक्चर है, जो हमारे सोशल रिक्वायरमेंट्स या ट्रेडिशन के हिसाब से सारी चीजें हमारा डिजाइन होता है। दूसरा जो वहां पर रिलेटिवली ये चीजें अब हमारा खत्म होते जा रहा है, जो हमारा क्राफ्ट्समैनशिप या जो भी सारी चीजें हैं, क्योंकि हमारे इसके लिए हमारे गवर्नमेंट की तरफ से कोई वो नहीं है, इंसेंटिव्स या उस टाइप की चीजें अभी नहीं मिल रही है, या मिल रही है तो कम मिल रही है। आने वाले टाइम में खत्म हो जाएगा। ये तो ट्रेडिशंस की बात कर रहा हूँ। अब मैं थोड़ा सा वो डिजाइन पैरामीटर्स की बात करता हूँ, क्योंकि कोई भी डिजाइन पैरामीटर्स जो अगर हमने जो स्टडी किया उसमें ये निकला कि सोशो कल्चर जो एस्पेक्ट है सबसे इंपॉर्टेंट है हमारे वहाँ। उसके बाद जो पूरा स्ट्रक्चर बनता है, वहाँ लोग कितना स्पेंड कर सकता है, अफोर्डेबिलिटी है, फिर क्लाइमेट है, जो मटेरियल एंड कंस्ट्रक्शन टेक्नोलॉजी है, सेफ्टी है, मेंटेनेंस है। तो ये सारी चीजें मतलब डिजाइन पैरामीटर्स, ये इसका सिक्वेंशियल किया हुआ है कि कौन सा किस लेवल पे इंपॉर्टेंट है, कितना इंपॉर्टेंट है। सोशल और कल्चर जो एस्पेक्ट्स है वो बहुत ज्यादा इंपॉर्टेंस रखता है। ये मैं आगे बता चुका हूँ, इनको स्किप ही करता हूँ। तो अगर आप देखा जाए तो बेसिकली जो मटेरियल्स या क्लाइमेट बेस्ड हमारे चीजें गवर्न होती है, वहां पर प्लान्स आप देखेंगे स्क्वायर या रेक्टेंगल है, कोई मतलब अनवांटेड शेप्स नहीं है। तो इसीलिए वो स्ट्रक्चर्स बहुत बढ़िया काम कर रहे हैं। हाइट या ओपनिंग्स जो है वहाँ के क्लाइमेट के हिसाब से बहुत बढ़िया किया हुआ है। आई विल नॉट गो इनटू, ये एक्चुअली कंपैरिजन था, मतलब हमारे अपर और लोअर हिमाचल में क्या क्या वेरिएशन है मटेरियल्स में, सिंस वी आर रनिंग शॉर्ट ऑफ टाइम। तो ये एक आपको अगर ओल्ड टाइप के कंस्ट्रक्शन को देखेंगे तो उसमें क्या है, मैक्सिमम यूज किया हुआ है स्टोन, मड, टिम्बर और स्लेट। जो टाइप ऑफ कंस्ट्रक्शन ये है काथकोनी है, ये अर्थक्वेक में बहुत मतलब इसकी प्रॉपर्टीज सब है। अर्थक्वेक में ये बहुत डिजास्टर मतलब बहुत बढ़िया वो करता है। बट अब प्रॉब्लम क्या है, इसमें मटेरियल जो है लकड़ी, और वो बहुत ज्यादा यूज हो रहा है, लकड़ी और पत्थर। तो हमारे को अब न्यू इंटरवेंशंस में ये सारी चीजें नहीं, मतलब नए डिजाइन में हम क्यों क्या करना है वो कुछ आगे मैं बताऊंगा कैसे करना है। और लोअर हिमाचल में कुछ इस टाइप का कंस्ट्रक्शन है। आई विल नॉट गो इनटू डिटेल्स, बट अनफॉर्चुनेटली अब जो कंस्ट्रक्शन हो रहा है वो ये बन रहा है। इसमें एक्चुअली विदाउट इंजीनियरिंग इंटरवेंशन हमारे को ये कंस्ट्रक्शन नहीं करे तो बेटर है। अदरवाइज अगर कोई भी अर्थक्वेक आ गया, इट विल बी अ बिग मेस हो जाएगा हमारा पूरा स्टेट में। ये जो बिल्डिंग्स आ रही हैं ये ताश के पत्तों की तरह कोलैप्स हो जाएंगे, क्योंकि इसमें जो भी इंजीनियर्स हैं, आर्किटेक्ट्स हैं, दे आर ओनली द मेसन्स। वो भी कहाँ से है, बिहार से, या मतलब आपको यूपी से मिलेंगे। जो प्लेन्स में काम किया हुआ है उनको हिल्स का बेसिकली आइडिया नहीं है, कैसा रिइंफोर्समेंट होना चाहिए, क्या होना चाहिए, दे डोंट हैव एनी आइडिया। आई विल नॉट गो इनटू डिटेल्स ऑफ दिस। नाउ आई कमिंग टू द लास्ट स्लाइड्स में ही हूँ। जो सिलेक्शन ऑफ जो है अप्रोप्रिएट बिल्डिंग साइट सबसे ज्यादा इंपॉर्टेंट है हमारे लिए। फिर उसके बाद डिजाइन ऑफ अप्रोप्रिएट हाउस टू सोशो इकोनॉमिकल एंड कल्चर पैटर्न ऑफ द सोसाइटी, वो इंपॉर्टेंट है। मतलब वहाँ के लोगों के जो सोशल इंपॉर्टेंस को हम अगर नहीं लेंगे, सोशल या कल्चर को, तो वो एक्सेप्टेबिलिटी नहीं है वहाँ पर। द फॉर्म ऑफ द बिल्डिंग शुड बी सिंपल। ये हमारे अजय साहब ने भी कहा होगा, रेक्टेंगुलर हो या मतलब उसमें जो लेंथ है, विड्थ का रेशो है, जैसा एज पर कोर्स होना चाहिए। मतलब एक्स एक्सिस और वाई डायरेक्शंस में भी मतलब वो सिंपल हो, सिमेट्रिकल हो, कोई आप अननेसेसरी मतलब एलिवेशंस या उसमें ना जाएं, जो कि मतलब अगर जाते हैं तो भी इट शुड बी प्रॉपरली डिजाइन। और दूसरा ये इंपॉर्टेंट सबसे ये है कि व्हेन वी आर डूइंग मड मोटार से हम अगर कंस्ट्रक्शन कर रहे हैं तो हाइट रिस्ट्रिक्शन हमारे को सिर्फ 1 स्टोरी तक का गवर्नमेंट को मैंडेटरी करना चाहिए हिमाचल में। अगर मड मोटार में हम कोई भी कंस्ट्रक्शन कर रहे हैं, अगर आप स्टोन ब्लॉक में कर रहे हैं, चलो, अगर सीमेंट मोटर में कर रहे हैं आप, यू कैन गो अप टू 2 स्टोरी, नॉट मोर देन दैट, क्योंकि सारा जोन 4 और जोन 5 में आता है। ये ऑलरेडी बताया था। ये जो है बिल्डिंग का शेप्स, मतलब आपको बहुत लंबे और ऊंचे इस टाइप के नहीं हो, मतलब वो छोटे छोटे सेगमेंट्स में जो कोर्स में कहा है उसके हिसाब से हम करें, ये भी है। और इसमें सबसे हिल्स के रिस्पेक्ट में ये सारे चीजें बहुत इंपॉर्टेंट है। वेदर वी आर डूइंग लोड बेयरिंग कंस्ट्रक्शन, अगर फ्रेम स्ट्रक्चर कर रहे हैं तो कोई अलग बात है। अगर लोड बेयरिंग कर रहे हैं, क्योंकि रेजिडेंशियल है, रूरल की बात कर रहे हैं, G+1 या G+2 तक हम जाते हैं, उसमें आप ये है वर्टिकल रिइंफोर्समेंट, पॉलिंथ बैंड, आपका लिंटल बैंड, रूफ बैंड, और दूसरा सबसे इंपॉर्टेंट है जब हम स्लोपी रूफ कर रहे हैं तो ये गेबल बैंड, ये सबसे ज्यादा इंपॉर्टेंट है। ये सारी चीजें हमारे को करना ही पड़ेगा, अदरवाइज हमारे स्ट्रक्चर्स गिर जाएंगे। और थोड़ा सा ये जो है कुछ में क्या नहीं करना चाहिए, क्या करना चाहिए, ये इस टाइप का कंस्ट्रक्शन हम अवॉइड करें तो ठीक है। कम से कम जो हाइट है आपका रिटेनिंग वाल के हाइट का, कम से कम इतना डिस्टेंस आप बिल्डिंग को छोड़ के बना दीजिए। और पीछे जो रिटेनिंग ब्रेस्ट वाल जा रहा है उससे कितना छोड़ना है हाइट के, मतलब वो सारी ये कोर्स में दिया हुआ है। और रिटेनिंग वाल्स कैसे बनाना है, ये सारी चीजें इट इज देयर। और अगर आप स्टोन मशीनरी का कंस्ट्रक्शन कर रहे हैं विद हाँ विदाउट मोटर ड्राई कर रहे हैं, तो ये थ्रू स्टोन्स, ये कोर्स में सब दिया हुआ है, इसके हिसाब से आप लोग करें तो बेटर है। और अब जो कंस्ट्रक्शन सिस्टम है, मैं बात कर रहा था, वुड वगैरह अवेलेबल नहीं है, तो हम उसको सेक्शन को पतला करके डिफरेंट जॉइंट्स प्रोवाइड कर सकते हैं, तो ये इंपॉर्टेंट है। अदरवाइज अगर आपके पास वुड बिल्कुल ही नहीं मिल रहा है तो यू कैन प्रोवाइड RCC बैंड्स। और तीसरा जो इंपॉर्टेंट है, ये कनेक्शन बिटवीन द रूफ ट्रसेस एंड वॉल। ये 99% आप केसेस में ऐसा मिलेगा कि वो दीवार पे रख देते हैं, इसका कोई इससे कनेक्शन नहीं है। वो अगर तेज विंड आ गया या कुछ आ गया तो ये सारे उड़ जाएंगे, या इस टाइप का कंस्ट्रक्शन किया हुआ है मोस्ट ऑफ द केसेस, मतलब उसके ऊपर उन्होंने पत्थर रख दिए हुए, सो इन केस ऑफ विंड। और अगर इन केस ऑफ अर्थक्वेक तो ये तो इसका जो पत्थर रखे हुए हैं उसी, अगर कोलैप्स हो जाता है स्ट्रक्चर तो लोग वैसे ही मर जाएंगे ये पत्थरों से दब के। तो ये इंपॉर्टेंट है। और इस टाइप का कंस्ट्रक्शन बहुत कॉमन है इन लोअर हिमालय, मतलब लोअर हिमाचल में। तो इसमें भी हमारे को जॉइंट्स देना पड़ेगा। अगर RCC का बैंड नहीं देना है तो यू कैन यूज वायर मेश अप टू, जो है कोर्स में दिया हुआ है कितने कितने तक देना है। तो इसमें बेसिकली जो इंजीनियर्स है हमारे, या जो टीचिंग आर्किटेक्ट्स है, उसके लिए ये बहुत इंपॉर्टेंट है। ये छोटी छोटी डिटेल्स हैं, बट दीज आर वेरी एसेंशियल। नाउ आई एम कमिंग टू द कंक्लूजन्स। जो भी हमारे को करना है, वी शुड अडॉप्ट साइंटिफिक अप्रोच। तो उससे फायदा क्या होगा, क्योंकि और उसमें हमारे को साइंटिफिक अप्रोच करके डिटेलिंग हमारे को बहुत ज्यादा करना पड़ेगा, क्योंकि अगर अनटिल और अनलेस वी गिव द डिटेल्स, क्योंकि जो इसलिए बोल रहा हूँ, और स्पेस ऑप्टिमाइजेशन, कॉस्ट बहुत इंपॉर्टेंट होता है रूरल में, कि स्पेस ऑप्टिमाइजेशन हमारे को करना ही पड़ेगा, क्योंकि आप अननेसेसरी बड़े कमरे बना दिए, पता लगा ऊपर जाके आपका कॉस्ट ही खत्म हो गया, तो पैसे ही खत्म हो गया। कॉस्ट ऑफ सर्विसेज बहुत इंपॉर्टेंट रोल प्ले करता है। आप कोशिश ये करिए कि लेआउट भी आप डिजाइन जब भी करते हैं, ये सारे किचन टॉयलेट्स वगैरह का सारा इकट्ठा आ जाए, तो यू कैन रिड्यूस लॉट ऑफ कॉस्ट। बाकी कॉस्ट इफेक्टिव कंस्ट्रक्शन सिस्टम्स ऑलरेडी है मार्केट में, देयर आर सो मेनी प्लेयर्स, मतलब लाइक CBRI, मतलब सो मेनी ऑर्गेनाइजेशंस जिन्होंने बहुत काम किया हुआ है और ऑलरेडी अवेलेबल है, नेट में भी है, सब कुछ है। और तीसरा इंपॉर्टेंट है, जो भी हम काम करें थोड़ा सा उसको एनर्जी के हिसाब से भी हम देखें, एनर्जी एफिशिएंट हो, क्योंकि एनर्जी क्राइसिस कंट्री में आने वाला है या आ रहा है। तो ये सारी चीजें हैं। अदरवाइज जो भी डेवलपमेंट हो रहा है अभी हमारे जैसे उत्तराखंड में, अभी ये ग्लेशियर का वो बहुत कितना बड़ा ये हुआ, कितने लॉसेस हुए, तो ये सारी चीजें मतलब छोटी छोटी चीजें अगर हम उन चीजों को अवॉइड करके हम करें तो वो है। ओरिएंटेशन, बिल्ड फॉर्म, मटेरियल्स एंड आर्किटेक्चर डिजाइन, वो ये भी बहुत इंपॉर्टेंट प्ले रोल करता है। मतलब जो है, मैं जैसे बता रहा था कि ऑलरेडी मार्केट में वी हैव सो मेनी थिंग्स, मटेरियल्स भी है, कंस्ट्रक्शन टेक्नोलॉजीज भी है, बट हमारे को उस वो मतलब रूरल में हमारे को काम करना है तो पता भी होना चाहिए, और वहाँ के जो ट्रेडिशनल कंस्ट्रक्शन सिस्टम है उसके साथ हम इसको कैसे मिला के चले, है ना। अगर हम दोनों चीजों को मिला के करेंगे तो हमारा कॉस्ट भी कम हो जाएगा, जो हमारा रिक्वायरमेंट है वो भी फुलफिल हो जाएगा। तो ये सारी जो टेक्नोलॉजीज है जो बात कर रहा हूँ, ये इजीली अफोर्डेबल है, कोई भी यूज कर सकता है। ऐसा नहीं है कि ये अफोर्डेबल नहीं है या बहुत टेक्निकल है, मतलब सिंपल आदमी मशीन्स को भी हम ट्रेन करके सिखा सकते हैं। तो बाकी दूसरा है कि जो मेरा मेन कंसर्न है, क्योंकि हमारे पास हिमाचल में, क्योंकि कंस्ट्रक्शन इंडस्ट्री एग्रीकल्चर के बाद दूसरा इंडस्ट्री है जहां पर बहुत पोटेंशियल है कि हम अपने लोगों को एम्प्लॉयमेंट दे सके। तो ये मेरा सबमिशन है या रिक्वेस्ट है स्टेट गवर्नमेंट से भी, ये आप लोगों के माध्यम से, क्योंकि हम वहाँ लोगों को ट्रेन करें। क्योंकि अभी क्या हो रहा है कि सारा लेबर हमारे पास या यूपी से आ रहा है, बिहार से आ रहा है, जो भी हम पैसा उसमें लगा रहे हैं इट इज गोइंग टू अदर स्टेट्स। अगर हम वहाँ के लोगों को सिखाएं, वहाँ के लोगों को करें, तो हमारी प्रॉस्पेरिटी और वो सारी चीजें बढ़ेगी। तो स्किल डेवलपमेंट हमारे लिए बहुत इंपॉर्टेंट है। बाकी नेशनल बिल्डिंग NBC है, बिल्डिंग बाय लॉज है, वो जो पर्टिकुलर रीजन्स का, ये बहुत इंपॉर्टेंट है, इसको भी हमारे को करना पड़ेगा, पढ़ना पड़ेगा और उसके हिसाब से कंस्ट्रक्शन करना पड़ेगा। विद दिस आई कंक्लूड हियर। ये एक टॉल स्ट्रक्चर है, ये इसमें है कुल्लू के पास कई इंटीरियर गांव में है। ये 8 स्टोरी स्ट्रक्चर है। इसने सारे के सारे मतलब डिजास्टर्स अभी तक जो है, अर्थक्वेक जितने भी आए हैं सारे इसने वो किया हुआ है, झेला हुआ है, तो अभी भी खड़ा है। तो इट इज अ वेरी गुड एग्जांपल और आर्किटेक्ट्स एंड इंजीनियर्स कि हमारे को जाके सीखे पढ़े क्या यार, अभी तक भी ये स्ट्रक्चर खड़ा हुआ है और कई सौ सालों से खड़ा हुआ है। इसी सेम कॉन्सेप्ट पे डिस्ट्रिक्ट किन्नौर में भी 3 या 4 स्ट्रक्चर बने हुए हैं, परंतु ये हाइट नहीं है। तो ये आप देख लीजिए, इसी के परमिसेस में ये एक दूसरा स्ट्रक्चर है। इसमें भी देखो मतलब एक आर्किटेक्चर को मतलब वो लोकल एनवायरनमेंट से कैसे मिलाना है, क्या है, स्लेट रूफ है, मतलब ये टोटल एनवायरनमेंट में ऐसा नहीं लग रहा है कि हालांकि अलग से खड़ा हुआ है, बट इट इज नॉट, ऐसा नहीं लग रहा कि कोई फॉरनर या कोई अलग से कोई ऐसा चीज नहीं लग रहा है, बट इट इज गोइंग टू द total environment. This I will conclude here. Thank you for giving me the opportunity. Thank you very much.
Thank you, Negi Saab. It's always a pleasure to listen to you. But due to some time constraint, थोड़ा सा explanation कम रहा. But इंशाल्लाह आगे फिर मौका मिलेगा. And it's always a pleasure to listen to you. So we are not going for a discussion, and we are just going for next speaker, who is Mr. Girish Joshi Saab. And I welcome Rajendra Bhai as well, Rajendra Desai sir, and Girish Joshi Saab to this program. So Garima ji, are you going to introduce Girish Joshi Saab, or Yogita, you are introducing? Please introduce Girish Joshi.
I'll do that.
Please go ahead.
A very warm welcome to Dr. Joshi, and we are very thankful that despite being so busy with the management of the recent catastrophe, he has still spared his time to be with us and to discuss with us the best practices from Uttarakhand. A brief introduction to Dr. Joshi. He has done his PhD and MTech both from IIT Roorkee and has over 15 years of professional experience in disaster management. He has coordinated various projects related to disaster management and earthquake engineering, funded by multilateral agencies such as World Bank, UNDP, the Government of India, as well as the state government. He has developed various educational and training materials, IAC materials and training modules. Many old buildings have also been retrofitted under his guidance in Uttarakhand. Some of the best studies like disaster risk assessment, river morphology and modeling, and development of decision support system in the state have also taken place under his guidance and supervision. Many scientific and technical papers and reports have been authored by him and published in reputed journals, and he has presented at various conferences. Presently, Dr. Joshi is working as a senior consultant in HPSDMA with the government of Uttarakhand. His primary role has been in ensuring effective and efficient implementation of various components in management of disaster risk reduction in the state of Uttarakhand. His knowledge has been facilitative in working with various specialized agencies, and he has contributed to the best of his abilities. With that brief introduction, we welcome you, sir, and we're looking forward to hear your experiences.
I also join Garima ji in welcoming Girish Joshi sir. Thank you so much for sparing the time because you are keeping so busy, and I hope situation is under control now, and everything is with you as well.
Thank you, Garima, and thank you, Amir sir. I think I am audible.
Yes, you are audible.
Yes, you are audible.
As you already know that, and you have also briefed out in this before beginning this session, we are busy in the rescue and recovery work, and lots of things have been going on simultaneously. So I have it is very less time to devote in this webinar because I had already 20-minute. At 1 o'clock there was a meeting, so I will try to be some brief on this session because most of the things has already discussed by Mr. S.K. Negi from SBRI, and my presentation is more or less little bit technical about this Koti Banal architecture or this structure which already Mr. S.K. Negi has been discussed, and we have done some studies and we have published some papers and some of this our publication in this international forum like this World Housing Encyclopedia regarding this Koti Banal kind of the architecture, and I am linking with these some of the best practices also because I have very less time to prepare for this webinar. So I think you give me this permission that I can share my this PPT. Just a minute. My presentation is there or not?
No, sir, not yet, sir.
My presentation is there or not?
No, sir, we cannot see your presentation.
Just a minute.
Yeah, it's coming.
It is there, sir, now?
Yeah, coming.
Yes, sir.
I am now going to basically this traditional Koti Banal architecture of Uttarakhand and Himachal Pradesh, and I am linking with the best practices of the rural housing in this Himalayan state. And what are the important structural and architectural feature? Basically, Mr. S.K. Negi has been also discussed some of the architectural features and these kind of the things, but how they have evolved these kind of the structural configuration in these structures, and what present in the present scenario we are lacking in our this developmental this kind of the projects. I'm going to be discuss this thing. I think everybody know this is the earthquake hazard map of the whole India, and you must know that we are in the zone 4 and the 5 as already S.K. Negi sir has been said, and this complete this northeast to the zone 5, and in Himachal and Uttarakhand most of the parts are in the zone 4 and the zone 5. And zone 4 and the zone 5 means the intensity of the earthquake may be more than 8 sometimes, and in terms of the magnitude, if you are talking about the magnitude will be sometimes maybe more than 8 Richter magnitude you can also feel in this region. This is the some of the history while we are looking how these techniques are involved, but uh, unfortunately we have a very less this scientific data of regarding the earthquake magnitude and this skin. But still, if you are if I am going to discuss that some of the major earthquakes in this region. So, like if you see that recently we have this Nepal, this Gorkha earthquake, and in the similarly after this one day there is that Dholka earthquake. These two magnitude, these two earthquake are the very near to the each other, and within 1 or 2 days, this is the big earthquake there. And then in the Kashmir earthquake in 2005, this is also the big earthquake and more than 7.5 Richter scale. Then this Arunachal, and this is the Bihar, Nepal, 1934. Then this Kangra earthquake, and this is the very important earthquake in Kangra earthquake, which we have described in most of the in the literature. We have seen that most of the buildings are damaged. Many collapses has been also observed in this earthquake, Kangra earthquake, and then also this Shillong earthquake, and this also this Garhwal earthquake, 1803. So if we are talking that about the Garhwal earthquake and this earthquake, so now so you see that these are the intensity scale of these earthquakes, and like this 1720, this Kumaon, then 1803 Garhwal, then Shillong. So most of the having the intensities are more than 8 and 9. So these are some big earthquake in this region. And recently in the Uttarakhand we have two earthquake before undivided UP 1991. This is the Chamoli, this is the Uttarkasi earthquake, and 1999 the Chamoli earthquake. Both earthquake are having very eye-opening to the what kind of the damages we have observed in these two earthquake. And after this 20 year, this is the Richter scale near about the 6 magnitude, or the same in between the 6 to 7 magnitude. But the if you see the damages, how much damages has have been recorded and how much losses. And after, if you are talking to the developmental of this area, and in last 20 years in this, because after formation of the new state in Uttarakhand and also in the Himachal part, but we are observing that most of the new constructions are going on, and how haphazard kind of the constructions they are in this region are going on. This will be the really a challenging issue, and the vulnerabilities are very high. And if you see that the vulnerability are increasing day by day in this region. And now this is the one of the famous Professor Wilhelm's this paper, and now you see that this is the reason, like this is the where the scientists are warning that, because you see this is the red means that this energy will be completely now locked there. So these are the reason. In this region, the locking line is like, we can say that there is more time, like I think the 300, 400 after years, this kind of the earthquake can be happening. But this locking line, when we are seeing the red is completed, means the earthquake will be due in this region. So the rocks are in this position, and recently we have done this disaster risk assessment study of this area, and we have done some trenching, and we are verifying the reports of Professor Wilhelm and the Wadia. And we have also observed that in this our report also, we have also mentioned that in this region, any time there's more than 8 magnitude. So this is the some of the epicenters of the major past earthquake in the respective Himalaya region. So that you can see the near about this Uttarakhand, Uttarakhand area, and also the Himachal Pradesh, and the western part of the Himachal Pradesh, and this north, this is the north part of the Uttarakhand also. So most of the earthquake we are observing many activities around the MCT. MCT is the major central thrust. In the major central thrust, we are recording these kind of the activities, and this is the very alarming type of the condition in this area. And this is the some of the photographs. This is the 1991 Uttarkasi and 1999 Chamoli. You see the some of the devastation of many of these mud houses and structures which having not proper earthquake resistance measures. So these structures observe that these are collapsed, and some of the death and casualties are also observed. So these are these kind of the been observed in these activities. So you can see, so there are complete collapse also. Complete collapse of the buildings has been also observed, because this is no earthquake resistant feature has been. You can see also that there is, as the Mr. S.K. Negi sir has been described, that these are no lintel band, plinth band. This is a no vertical reinforcement in this structure, and this is a completely damaged in this structure. So you can see these are the some cracks in the some of the in the structure. So while we are comparing that major losses in the moderate earthquake magnitude, so in the 1991 and 1999, so human lives are more in Uttarkasi and Chamoli, more or less both are the similar kind of the earthquake. But if you see the damages of the houses, so it is near about same. Near about 75,000 of the houses has been observed that damages. And in the Uttarkasi, the casualties are more, because this is the region that peoples have adopted some modern structures. They have changed their old structures, which having some earthquake resistant feature, as in the previous lecture you have seen. But due to the comfort and these kind of the thing, these people have changed their and this for the comfort, for the point of the comfortability, they have changed the structure. And then we found that some of the area of the Uttarkasi, like this Jamak Gaon and some of the Gaon at some of the villages at near upper side of the Uttarkasi. So some of the villages having this death reported more, because due to this these kind of changes in the structures. So this is the typical residential built environment. And if you go to the any hill, like the you can see in the previous presentation also. So this is the typical environment. If you visit to the hill area, so you find these kind of the structures and predominant. And this is the typical hilly environment, and the peoples are know about that, how they can be live in this, like that, for their comfortability, from the point of view of their resources, how to use the maximum resources they can utilize from the nature. So this kind of the environment you can find out. And this is the one of the area of the Kumaon area. If you go to the Kumaon area and this in the Uttarakhand, so you can find that this kind of that. So both kind, you can see that in the flat terrain, flat kind of the area, the peoples are mostly living in the flat area, not and in the upper side of the hills, but in the flat area they are generally made. So this is this is the Koti Banar architecture, and this is the what I think some different name has been said by the Kuthi company. I think I am not exactly spell out this name, but we have given this name the Koti Banal of these structures, because this architecture has been evolved in this Koti Banal region. Because if you visited in this Koti Banal, you find the thousands of the houses of the same kind, and you see these are the buildings which are still erected there, and these peoples are know about how they can make their structures. And we have done some detailed study of these structures, and at the point of the architectural point of view and also the structural point of view, we have done some studies, and we have done some modeling kind of the thing of these models. And then we found that how meticulously these structures has been designed and they can make. And this is the long back, if you see, and this is the map where these kind of the structures. So if you go to the Himachal area, so this is the southwestern side, and in the Uttarakhand, this is the north and northwestern side. So this is the reason where most of these Koti Banar architecture has been evolved. This is the one kind of the architecture school which was developed there, like this Dhadji Dewadi in Jammu Kashmir region. The same kind of this Koti Banar architecture have been developed in this area. So this is the 1910. This is the Middle East have been prepared this sketch. So at that time there was no camera, such a high resolution kind of the camera was there, but they have how they have derived these kind of the structures was found in that 100 years back in this structure. So they have sketched out in the Kangra Valley of Himachal Pradesh. And now if you observe, like in the previous presentation, like if the 8-story building as the Mr. S.K. Negi sir has been showed to you. So these kind of the structure, and this structure what I am showing you, this is the 5-story building. So field study of this area, then we found that these structures are called, the names are different, like that this 4-story are called the Chokhat, and this 5-story are called the Panchpura in this area. So most of these Panchpura and the Chokhat are you have basically, and Panchpura are for these people, like for the temple, as the temple kind of the thing, and some of the if some a leader of the society will be have been also residing on these buildings. So this is this is the Panchipura and for the Chowka. The main investigation about these kind of the Katiguni or this Koti Minar architecture is that this construction type has been practiced more than 200 years and currently not being built. Presently, it is not being built by anybody because you know that, as the previous speaker has also said, that this the main requirement is the wood and this stone. So the wood and stone most are now that this is prohibited now in the region, and this 200 years of the practices they have evolved these techniques, and we have done the carbon dating of this building material, and you all are I think if you go to our report also, you find out we have done this carbon dating of this wooden part also, the stone part also, and we found that this is near about 1000 year back. And this is a very astonishing thing with us also, because while we are discussing, we are reviewing and we are researching on this kind of the structure. So many of the structure we found that is more than 800 year back. So now what I think you must know that while the engineering will be started, before the engineering there was a concept of the force, and the concept of the force was given by the Newton in the 16th century, and these structures have been built near about 800 year back. So now you know how these peoples are capable, these artisans and these Raj Mistris, what we are naming it the Raj Mistri. Raj Mistri means they know the secret of the buildings basically, and these peoples have been now evolved these kind of the techniques, and by their because you know that earthquake is not a newer thing. Like I have shown you that on my slides also, most of the earthquake now, if you are living in this Himachal area, Uttarakhand area, and many times you are feeling this shaking, and these people are also the same kind of the experiences, and these experiences have given this side the insight that we built a structure which are basically the earthquake safe or the disaster safe kind of the thing, and these structures are generally not in the valley side. Now presently what we are basically doing, I'm sometimes very much amazed by how the schemes we are designing in the government, like in the recent flood also in the Uttarakhand area. You see the complete valley, no single person from the village has been died in this event, because everybody is living in the high hills in this area. The people who are died in this disaster are mostly living in the valley, because they are working on the site. I think this is a Rishiganga project. So this is in the valley side. So the people who are washed out in this event are living, because they have no choice, because they have to build these houses. So now these all valley constructions are going on. If you go to the many of these regions, like in Himachal Pradesh and Uttarakhand, you found out that the people are living near about the roadside, also near about the stream side. And where these streams are, because the stream having some, this is the return period of any flood, return period of any event. Like if you are saying the earthquake, there is some return period. After the certain year, this earthquake can be come back. So like in our codal provision, like IS 1893, but we have defining the earthquake in the two part, like the design basis earthquake and the maximum credible earthquake. So how we are designing these kind of the structure? This is the big question. And what we have find on this structure is that similarities in the architecture principle and structural details as that the possible evolution under one single architecture school. This is one of the finding, because with some of the Norwegian scientists and the IIT Roorkee Professor Yogendra Singh, we have find out that this is the one single architecture school kind of the thing, and this was evolved after this 200 year of this. So now this is some of the architectural aspect. I think Mr. S.K. Negi has also discussed this, but you can see some of the silent feature of these kind of the building. This is the located at but we can see that this Koti Minar are generally close to each other. People are living very close to each other, and so their society has been involved in the one. If you go to the hills, then you find in the some of the area which is very suitable for making such kind of the housing. So these kind of the structures you can find there. And the build configuration, because the build configuration is a very important part. So build configuration, if you see that the Koti Minar buildings are characterized by a very simple rectangular plan. And very rectangular plan, what we have find out, and what we have measured that the length and width are varying between 4 to 8 meters. And but we have also now, we are saying in the code also nowadays, the ratio between the dimension is 1.1 and 1.4. So it is also written in our code that the dimension should be more or less 1 from 1.5. So the ratio we have found the dimensions are the very this one. So this is the, we have drawn some AutoCAD drawing of these buildings, and then you can see that this is the single unit building, and if some having the single unit, and if the some families we are living in the dwellings like the double unit. So these peoples having that in the two sides, they have these kind of the structures. So now if you see the detailing of the cantilevered balcony construction at the fourth floor, so this is the one of the important part what we have found. The balconies at the top floor, and this is the, and what we have also observed is this top part is completely made up by wood. So there is no stone we have found here. So they know the concept that the lower parts will be stable. So the most of the wooden, most of the stone and heavy stone part has been used at the lower side. To the upper top side balcony is only for the wooden logs only. Now, if you see like in the previous presentation, you have also seen. So this is the foundation. So foundation is raised platform, and this is the 2 to 4 meter most of the buildings, and this is at the solid platform. Found that this is on the solid platform, and then wooden frame being made. Wooden frame has been inserted, and then this is connected to this ground. This is the ground at the platform. This is the platform at the ground. So this is the elevation. This is the elevation. This is the elevation of the 5-story structure we have drawn, and this is the inter-story height is the 2.2 to the 2.5 meter what we have observed. So this is the one of the important thing. Nowadays we are also saying that in the codal in our code also that this inter-story height should not be changed very drastically. If its inter-story height will be changed, and there will be some weak story kind of the collapses. So these people, I don't know how they understand this kind of the thing, but this inter-story height has remained very constant, and also the height is very less. Rather, they have some problem while they are going inside to this building, but the height has been observed that this is a 2.5 meter, most of them not more than 2.5 meter of the any of the story. And this is the plan side and the front and rear elevation of the Koti Nala architecture. So what we have done some straight and on this structure, and then we have this is the whole complete figure, and then each and every blocks, like each wooden part, every stone part, and then we have defined the properties of these stone and every wooden part, and then we have found out they are basically, this building are reacting in case of any earthquake. So this is the vertical cross section illustrating the wall construction principle in the lower carriage part and the upper part. So you can see that how the shear pin, this is the called the gujja or the khunta. You can see these are the gujja and khunta. This is the one of the very important part, and this is the part is the closely packed stone are there, and these timber logs are there, and between these dry stone masonry, this is the completely, this is a flat masonry. This is the completely flat and dressed stone. There is no undressed stone we have found in this structure. And this is the timber log are there, and this khunta has been also from the foundation to the top. This khunta has been we have observed, so that the complete intact of this building, and also this is also allow some ductility to these buildings. So ductility is also you can we have observed that some ductile kind of the thing. Otherwise, these structures cannot last for 700 or 800 years, because they have most of these earthquake. This is the most of the earthquake reason. And I think we have documented some of the big earthquake, but there's some small earthquake like 6 or 5 magnitude. I think this was not documented in any of the book, any of the history book, or any of this kind of the book. But we have found that these structures are still intact, and presently this intactment has been lost due to the peoples who are basically the owner of these. Their ancestors are owner of these, so they have took out this devda tree. This is completely by the devda tree, and the devda is the one of the best tree and having the best quality of the how they can survive in the this kind of the nature where this kind of building has been made. And also the arrangement of the wooden log and the well-dressed flat stone for the wall. So you can see that the open space and height is 30 centimeter between the horizontal log. impact, and we can see the lintels are also or by the using the paste or the some paste they have also, like that so dal hoti hai hamari, the pulses they have used sometimes in this, so that they can intact if some stone are not intact. So we have found these kind of the things in this structure. So this is the arrangement of the wooden log, and you can see the how these wooden logs have been transported there, how they have built there, and then these stone blocks are there. So these kind of the structures are there, and between I will also in the structural part I will show you the how these khuti has been also inserted in these buildings. Then the walls are, the thickness of the wall is determined by the thickness of the two parallel arranged wooden log, which is the mostly between 50 to 60 centimeters. This is also observed in the most of the building. The structure is further reinforced by the wooden beams, which are perpendicularly attached to the wooden log at the middle and the wall, which I have shown in the last figure. So you can see this, so how they have prepared it. Beams are provided by the joists supporting to the floorboard. So that this is the timber log, and then this is the wooden planks are there, and this is the wall thickness. So this is the complete detailing we have done while you are going to for the World Housing Encyclopedia report number 150. So you find the complete detail on this kind of the structure there. Safety against overturning. So this is the one of the important feature what we have found here. The wall is parallel to the floor beam, are supported in out of plane action. So generally what happens, the structures are generally fail on the out of plane. So they have provided the large timber log longer than the building dimension and the hole at the two ends. So this can be resist in case of the out of plane failure of the building. And the vertical member, this is the one important part which are nowadays we are also saying in our codal provisions, like this 13920, where we are saying the ductile detailing. The shear key is a very important part, and the shear key they have inserted 700 year back in this structure. I will show you some shear key example. You can see this is the shear key, and the every part, if you go to the back part or the side part. So you find this shear key, and this shear key is completely from the bottom to the top. So while this earthquake will be going on, so this will be provide the complete ductility to the building, and building resist this kind of this is the complete shear key which they have provided. So this is the one of the important funding on these buildings, and like if some researcher are in this webinar, so I request that you go there and then you do some finite element, because I have not done the finite element analysis of these buildings. So if you got some finite element kind of a thing, then you find the real interaction between these, how these shear key has been has been very useful to resist the earthquake forces there. Then the opening, and the opening is a very important part in any kind of the structure. So as nowadays we are also saying that in our modern structures, which are the masonry building or the confined building, so we are saying that the opening should be very small. So while we are going there and while we are studying this structure, then we find that the openings are very small. And the strong wooden element, which we have nowadays also saying in our codal provisions, that if in case we are going for any of the window opening, then in the window in the all side of the window we need some beams kind of arrangement, so that the window will be the strength which was lost due to this window opening will be also compensated by these kind of the strength. In general, no window are provided at the ground. So that one of the very important finding is that no window are provided at the ground floor level. So this is the, if you see, and the detailing of these window opening and these kind of the structures. Functional planning, if you are talking about the functional planning, the main functions of these buildings are a single family. Generally, the single family are living, but sometimes we have found also that two families are also, two brothers or some kind, they are also living in the close to each other. The access to the upper floor is only provided by the wooden ladder made by the single. I will also show you in the ladder. So only this wooden ladder, and what is the use of this wooden ladder? I will later I will show you what are the functional purpose of these kind of the things. Due to massive walls, some of the building have also been built. This is the main reason. That's because sometimes in 300 year back or 400 year back, when the British or the Gorkha army have been also in this area, and they are coming there for making their for their state, their presence there. So this army has been also invest in this area. So what they have done, they make this kind of the wooden trunk simple. This is the ladder, and this ladder you can anytime you can detach it. So if you detach it and you close this door, so nobody can insert it, because at that time there is no such kind of the bombing or this kind of a thing. Only the people can come there, and they have some old kind of the old type of the this like this talwar and these kind of the thing. So these peoples have also know that the safety of these their peoples also, and they have provided these kind of things. So you see, this is the ladder. So if you detach this ladder, so you just give one push to this ladder, and this ladder will be detached from the totally upper structure, and then you close this door and you will be safe inside it. So this kind of the arrangement they have also done for there. And as you see that like in the latter part, when this is school of architecture has been developed, what we have found that in the 13th century and the 14th century, most of these Koti Banala original structure has been evolved. But after that, what happened, that people are more on the functional part, like the comfort part. So they have changed some of these structures. So you find this is the some of the arrangement of the veranda and these kind of things. And but we have observed that due to this, by the modification of this architecture, so the wooden log are, you see the wooden log, the wooden log has been reduced here also, and you see the no wooden log there, because they need some height of this story height they want to change. So they have changed the story height 2.5 meter to the 3 meter or 3. So now nowadays what we are doing also in our modern practice, we are more in the architectural point of view. If we are going for any of the buildings, so first we go to the any architecture, and then ask to the very lavish kind of the thing, veranda and the very big balcony, and then the big rooms also. So same kind of the philosophy, I think they have also at that time, after 15th century, they have also know that comfort is more important. So they are lacking on the structural part. So these are the some structures which we have found, which are totally now detached there also. Now this is the structural detail. So this is the what we have found, that this is the two kind of this is the hybrid system. So what we have found that, but detail analysis can be done in the near future if somebody is interested. So they can go for this hybrid kind of the timber reinforcement stone masonry. So two kind of the systems are there. This is the gravity load resisting system and lateral load resisting system. These both combination are inside it, and what we have named in this world housing encyclopedia, this is called the hybrid system. The system, in this system, what is the system of the horizontally pair of the wooden log, which are connected to each other by the wooden shear pins, tenons, act like a wooden frame, which is braced by a well-dressed flat stone in between the logs, increasing the bearing and increasing the bearing, the lateral capacity of the construction. So this kind of this is the structural detail of this building. So like this is the structural connection. So some buildings has been now, people have taken out the woodens and the stones because for their modern construction. So you find that these kind of the details are there. So you see that this is the gunji, khuta, these kind of the things are there, and this is the running from the bottom at the foundation. These are the khuta kind of the things they have figured. So we have taken these pictures, and then we have also inserted to our models that this wooden properties of how this kind of the interlocking has been done. So you can see in the close, this is the housed and nailed joint used to fixing the wooden. So you can see this is the housed and nailed kind of the thing. So these wooden structure they have created for this horizontal forces which they have generally experienced. Another is the floor and the roof system. So the wood planks resting on the wooden joists supported by the beam or wall. The floor consists of the wooden beam and the plank. Mostly the floor are wooden beams and the planks. Since no cross inclined plank are there, it is expected to act like a flexible diagram. So because the no cross linkage we have found, the floor beam are shear pinned with the wall logs, and thus provided support to the wall orthogonally to the beam in out of plane action. So this is a very important part, that in the out of plane also they know that the force can become from the any side, from the origin, from the in plane side also, from the out of plane also. Wooden plank or beam are supported by the slate tile. So this is the wooden roof, and this is the some of the, I think the slates are very, this is a very low weighted slate what we have found. Nowadays the slates which are using most of these construction are some heavy, but this is the one of the deficiency what we have observed here. But they have registered this deficiency by using some another technique. So they have while they are providing this kind of the slate, and beneath of these slates, this slate roofing, they are very good wooden packing are there, so that if some slates will be broken down or in case of the earthquake, so they can replace it and they can use it properly. Seismic performance, what we have done in the state, using the actual static method and the design base here, the Koti Banal structure has been computed to the in order of the force what we have calculated is the near about 700 kilonewton, and this is the near about 23% of the total seismic weight of this building. So this is a huge force they are now taking of these kind of the buildings. And detailed investigation of the number of the building in the area clearly reveals that the age-old structure are still intact, and even the non-structural component have been not damaged. So if you go there and if you find that most of the structures are, you can find the not damaged also, and it's in zone 4, most severe zone. And the age of the building clearly suggested what we have found after the analysis. So the building will be at least have been observed the design basis earthquake. Design basis earthquake in the layman language I will tell, this is the earthquake which are returning near about 475 years back. So any earthquake which are like the more than 400 year return period, so this is called the DB, design basis earthquake. So these kind of the shaking they have already experienced in the structure. So this is the distribution of the forces that we have find out. So you can see it, and if you go to the detail, then you can check out. If you go to the report also in our, so then you find out how we have calculated these kind of things. So this is the seismic feature. So but in this table I want to share you that this is the structural element, and some are the seismic deficiency also. But for countering this seismic deficiency, what they have done the earthquake resident features also, and what kind of the earthquake damage pattern we have observed there. So a structural element is wall, and suppose we can say the wall thickness is up to the 1.5 meters. Nowadays we are seeing that more than this kind of the high dead load is there. But in the similar time, but the earthquake resident feature is there. There is a flexibility during the dynamic shaking, since the no rigid mortar is used between the stones. This is the most important thing they have done there. Another is the bearing capacity is too high to load for the vertical loads. And third is the prevention of the out of plane failure through the shear key. So these three arrangements they have already done there. So the no damage pattern caused by the earthquake have been evaluated. So we have we have found there is no earthquake kind of the damages we have observed till after this. This is a centuries of the centuries has been now gone out, but there is such kind of. Another is the frame. This is the block house style wooden frame. So there is no seismic deficiency, but there is no, but the architecture are very more like the special load bearing structure also. Bearing of the shear forces through shear pin, tenons connection between the wooden blocks. So this is the very important part, but I have also shown you in some of my photograph. Flexibility and the weather resistant due to the Devdar timber. So this is the very important part, like our previous speaker has also said that the comfortability of these people, because in this area is the high altitude near about the 4,000 meter and 3,000 to the more than 2,000 meters. These kind of the structures has been evolved. So what the temperature is very low. So this height and these kind of the structures which having the wall thickness is more. So and the Devdar trees are very important. This is the most integral part of the structure. So the temperature remain very temperature is very warm in this these kind of the structure. Beams are mostly rectangular in shape. And this is the width to height ratio is 2:3, and cross section area is larger than the needed to the adequate surface. So cross section area is always, you can find if the cross sectional area is more, and the earthquake this width to height ratio can be also regulate your earthquake forces. So this is the very important part that they have also incorporated there. Another is the opening are very, if you see the opening are surrounded by the wooden element which are in our various codes also. That if for the seismically active zone, this is a very important feature that the opening should be less, and if opening will be given, then it could be connected by the different kind of the beam and connection. Another is the roof having some seismic deficiency, like the high load due to the heavy roof material. This is what we have found. But inverted pendulum effect due to the concerned mass at the top, because some part at the top we have this slate kind of a thing. In the lower part, there is the wooden part, but another is the flexible diaphragm effect we can also observe in this. This is not a rigid kind of the thing. But another important earthquake resident feature is the large dimension of the upper story, thus leading to the higher story masses is compensated by the use of the less stone and the more wooden. But I have already told in our previous my slide that the wooden part is more, so the flexibility has been more. So there is flexibility more is in case there will be some damages, they can be recovered very fast also. Another is the floor. The floor is the flexible. So in the case of the flexible diagram, we found some of the, this is one of the deficiency, because we need some rigid kind of the diaphragm in case of the earthquake. But the same time, the earthquake resident feature is there. Floor beam that runs from the middle of the one wall to the opposite wall provided additional stability. So this is the one additional stability they have already provided to tackle this flexible diaphragm effect. So we have also observed no earthquake effect. Another is the socio-economic effect. I think this was also discussed by the Mr. Eskinegi also. The number of the inhabitants during the evening and night are 5 to 10, but we have observed, and we have made them questionnaire in this side area, and then we found out. Pattern of the occupancy is the generally the building having the single room or even floor which are vertical distributed uses. While the ground floor is used for the cattle or grain, generally they have used for the cattle, as you know that the lower side, and the upper floor are used for the living and bedroom. The kitchen is generally at the top floor. This is a very important thing what we have found. Kitchen at the top. Why it is at the top? So what we have observed that because at the kitchen, because they are generally used as this fireplaces and these kind of a thing. So in case some fire will be broke down, so it will be only affect the upper, because generally fire when broke down, it is generally not go to the downside. So this is the upper part they have made this kitchen, and they have some functional problem, but they have created such kind of the arrangement. And I thought that at that time maybe sometime they have this kind of the disaster has been also they have also observed in this while they are living there. So they have shifted their kitchen to the upper side. So this is one of the important. And some of the building are the dry toilet at the cantilever. So at the top part, while we are saying, so this is the part you see. These are the some holes are there. So you can use some like wash basin kind of the thing. So you can, in case of the sometimes when some invaders are there, like that the British Army, Gorkha Army will as was go in this side to conquer these places. So what happened? So these people are living at the top place and they can use their daily kind of the things. So they have used this kind of the. So this is the top floor. You can find at the punch.
Joshi, sir.
Not in the chalk. Yeah.
Sorry, sir, but we are just pressing with the time. So kindly.
Yes, yes. I'm just finishing this.
Thank you so much.
And the economic level of the inhabitant at the time the construction, the builder definitely belonged to the very rich society. So but nowadays I am saying that we are now saying that the peoples in the villages and the hills are not very rich, but my observation is that these belong for the rich social class. Otherwise these kind of the building has been not evolved in this area. Ownership, the type of ownership or the occupancy in this owner are the group of peoples are living in the pools, and the number of the many of the documents. This is my conclusion is now. The Koti Minar architecture attained in the zenith around 880 to plus minus 90 years. So it is near about the 1000 year back. And this is the some of the masterpiece, and we need to be documented. We need go for the detail, and we have also given to the government 10 year back to make this as a homestay kind of the things. And we are happy to inform you for the gathering that some of the structures are now they are using as a homestay in the some of these areas, and government is providing some soft loan and these kind of the things to these people. Main constituent of the Koti Minar architecture are a simple layout of the structure. Number 2 is the construction on elaborate, solid and raised platform. Third is judicious use of the locally available building material. Incorporation of the wooden beam all throughout the height of the building at regular interval, small opening and the shear wall. So this is my last word for this. The Koti Minar architecture need to be studied and documented in much more detail. Intricacies of these age-old construction style have the potential of unfolding a new line of the construction that might be the better suited even the present ground realities of the region. So for the region specific kind of the things, and then the hills now but we are building different kind of these RCC structures and these kind of things. So we have to learn about these structure, and then we can evolve some new structure, new methodology and new structure kind of the thing for the hills, which will be some modern kind of the living style also, and some safety kind of the concern. So these are some of my papers and reports. If you want to go there, and then you can download from the internet from anywhere, and then you can. Thank you very much. Thank you.
After that,
Thank you so much, Girish Saab, for a wonderful presentation. It's so detailed and so nicely presented. The only thing is it's a time constraint on your part as well as on our part as well. So this is the only thing, the limitation. And the only one question to my mind at present is that how much do those night stay people charge?
I think, sir, I don't know. There are 2-3 people's, 2-3 villages. This kind of the structures are using. I will inquire and then tell you कि what are they are charging.
No, क्योंकि उसका प्लान बनाया जा सकता है. This is the fascination for all those fraternity of earthquake risk mitigation experts जितने भी हैं, है ना. तो एक दो दिन तो बनता है उधर जाके उसमें रहने का, बच्चों को दिखाने का, तो फैमिली के साथ जाया जा सकता है.
You sir, and some people are there because the ये tourism department वाले उसको देख रहे हैं. So I will inquire and tell you. I think very much cost.
I think so, yeah. So it's quite fascinating,
and you can enjoy the pahadi food also.
Yeah. So we are not taking much technical question right now, as you are also pressing for time. You have a meeting slated. So thank you so much for sparing time in this busy schedule, and definitely some other time exclusively on this we will discuss with 1 or 2 more experts to critically analyze this Koti Banal in form of a webinar or so. So thank you so much, and we are now, Rajan Bhai is waiting for quite some time. Rajan Bhai, sorry for keep you waiting, but things are beyond our control. But
I had a privilege to listen to Girish and Negiji, so it was very interesting.
So you are in the same league, sir. So you are also going to give a very interesting presentation come discussion. So not taking much time, Garima ji, if you have to add some words for introduction to Rajendra Bhai, that's all.
Yes,
and otherwise we can directly go to that.
A very warm welcome to Dr. Rajendra Desai. He has an illustrious academic record and is a professional who has been working for very long in this field. He is presently serving as the Joint Director and Managing Trustee of the National Center for People's Action in Disaster Preparedness. He has obtained his MS Civil Engineering in 1972 from the Rutgers University, New Jersey, USA. After that, he has gained 20 years of diversified experience in technology development and transfer, structural design, disaster mitigation and rehabilitation, repair and seismic retrofitting of masonry structures, assessment and improvement of vernacular building systems, site development in India. He has over 13 years of diversified civil engineering experience in the US. Dr. Desai has worked as an associate member of the Earthquake Engineering Research Institute at California, USA, and is also a life member of the Indian Society of Earthquake Technology. Since 1997, Rajendra Desai ji has been a consultant to the Government of India, the UNDP, the UNESCO, Gujarat State Disaster Management Authority, Asian Disaster Preparedness Center at Bangkok, and Oxfam India Trust. He has published a number of guidebooks for the common man. He has designed an ongoing training program for skills upgradation of existing masons that focuses on earthquake construction primarily in Gujarat and other parts of the country. He has won many awards, including the AS Arya University of Roorkee Award 2000 for disaster mitigation and Hari Om Ashram Hadko Award for dissemination of earthquake resistant housing technology in Latur in 1996. So we can't wait to hear from you, and over to you, sir.
And Rajendra Bhai is no doubt one of the eminent experts working at national level. So Rajendra Bhai, there is no agency where who is working on earthquake risk mitigation, and Rajendra Bhai has not been involved for that agency at national level or even internationally. So he is one of the most renowned expert in the area of retrofitting of structures, and he has worked. I think for last 30 years, I'm very confident that he has not missed out a single earthquake since Uttarkashi earthquake of 1991. So since then, I'm very well aware about his credentials, and I can vouch for anything on retrofitting related activities to Rajendra Bhai. Not taking much time, but this is your turn, Rajendra Bhai. Thank you.
All right, thank you very much. Amazing. So I'll have to make sure that I give a good presentation. All right. I'll just start sharing. Sorry. All right. Okay. All right. I'll be talking on retrofitting, and it's basically I've been working on retrofitting since 1994. It's been a lot of learning, and has been done with passion, and that's what is needed when you get into a new field. So start basically what I'm going to be doing here, I'm going to be talking about masonry buildings, not RCC buildings, because that's basically what rural scenario is, although it is changing. But two are completely different animals or species, and their handling is also completely different. So it's not possible to cover both in one presentation. So this is basically what I'm going to stick to is masonry. All right, let's start. What is retrofitting? Basically, it means to add or substitute parts or components to a device or a structure to make it fit the given context, which means that you have context for which the structure wasn't made or the context has changed. You know, so if it's not made for earthquake, then you need retrofitting to make it fit the context. Now, typically in industrial facilities, you know, I mean, like for example, there is a pipe that is carrying some fluid, that pipe size is increased. You know, then the support structure requires to be stronger. Or you have your variety of equipment, and suppose a larger equipment is brought in, then you need the support structure which is strengthened. So in both these cases, the support structure is rarely demolished. Okay, you know, because it costs money, so it's much easier to strengthen it. Okay, so basically, I mean, same is the true for situation against disasters, against earthquake. That if it's not built to resist earthquakes, then we need to retrofit it. Now here are numbers of some of the past earthquakes, although this is not really up to date now, but the numbers run into thousands and lakhs of damage, destruction, deaths. So the whole issue is that, you know, whether we want to be part of such sad statistics. Now, although, you know, I'm supposed to be talking about earthquake, you know, but when we talk of natural hazards in an area, you know, is the seismic hazard, wind hazard, and flood hazard. And of course, Himachal seismic hazard is the most predominant. But of course, there are a lot of locations with high speed wind, you know. So the buildings which are vulnerable to a particular hazard are likely to suffer damage, and as a result, they pose danger to the occupants when the hazard strikes. So such vulnerabilities can be reduced, if not totally eliminated, by retrofitting. All right. Now, why opt for retrofitting instead of rebuilding? You know, when you rebuild, of debris and reconstruction, and each of the steps costs money. Right? So naturally, you know, retrofitting, on the other hand, is essentially making small changes to some components of the existing building. So needless to say, it's going to be much cheaper. And one sort of thumb rule is that typically retrofitting would be about 5 times cheaper than reconstruction, or be 20% of reconstruction. And needless to say, it is much faster. You know, I'll say 5 to 6 times faster than reconstruction. All right. The reconstruction means redoing all the conveniences created in the house. You know, you construct a house and you make it a home by doing so many things. All right. Reconstruction means doing all of that again. Retrofitting, you know, in retrofitting, you may lose some of it, but not most of it. All right. Okay. Another major advantage of retrofitting is that it can be done. It may mean, you know, you do part of the building retrofitting right now and part of it later. And the major advantage of this is that it is more easily manageable economically. All right. If you don't have enough money right now, you do retrofit part of it right now and part of it later. And secondly, even if the building is in use, it can be retrofitted. because you do it in phases. All right. Now, one very important thing is that retrofitting results into huge savings of national and global resources. It's high time we started thinking in terms of global resources. Okay, and it has much smaller carbon footprint than rebuilding. Okay, this is a very, very important factor. So today, for me, more than the earthquake, it's a climate change is the biggest disaster, and it's already here all the time, right? I mean, the recent event in Uttarakhand is an example of that. But we have monsoons failing and all kind of, right now in the US, in the winter, in the US, which is typically very hot, it's snowing. Okay, in the last 3 days, the temperature are sub-zero. So it's a very, very scary scenario. And carbon footprint is the most important parameter that one has to think of, especially when you get into construction activity. All right. The greenest option for reducing vulnerability, and it's the most efficient option. So it can ensure the long-term safety against future earthquakes for most number of people with least amount of money. All right. Let's look at this dimension. To reduce vulnerability and ensure safety. What has happened in the past? The most common approach that we have observed disaster after disaster has been to demolish and rebuild, since it is easier to work with clean slate. All right. But the question is, there will be enough resources to demolish and rebuild all the vulnerable buildings? Would it be better to restore and retrofit these buildings so that scarce funds can go longer? And of course, it'll have much, much smaller carbon footprint. So I think we should be saying no to reconstruction unless the building is badly damaged or the building is highly dilapidated. And it should be yes to retrofitting. All right. Just very quickly, in the last 26 years, we have worked sort of all over in almost all these seismic zones of the country, disaster after disaster. And, directly we have been involved in the retrofitting of over 800 masonry buildings. All right. And it's been a lot of learning. So what I want to share here is learning very, very fast how to retrofit a building. All right. Basically, you need to know everything about the building. So you have to document it. If you have as-built plans, fantastic. But otherwise, you have to create that. All right. Based on that, you identify the weaknesses, you identify the remedies or the retrofitting measures. All right. Repair the damage. Whatever damage, if there is any, especially the post-disaster situation, you repair it. You basically, so that you restore it to the original state. Next, you decide upon the sequence of operation or retrofitting and the phasing. Are you going to do it all in once or in stages? All right. And you procure the materials, you procure the retrofitting, and apply the measures. And ultimately, you finish it to match the original finish, to hide it. Or as we prefer to do it, we like to highlight the retrofitting measures. They should be visible. What is it? So that you can tell them it's retrofit. All right. And one of the most important things, along with the plans, elevation sections of the existing building, what you also need to do, especially if the building is damaged, is to draw fold outs of each. As you see here, it is ABCD. So it is folded out. You see the elevation of every wall so that you can see exactly what damage there is, what grade it is, what is the extent, because this will tell us what needs to be done. All right. Now, there are a few examples of vulnerable buildings. They are in Himachal, Uttarakhand, Kashmir. They're all pretty similar. Basic construction is not very different. Your random rubble masonry, some of it will dress, not dressed. But the upper photographs, you see there are no earthquake resisting features. Down below, you see a mix of stone and brick and a very thin brick wall and nothing to restrain it. And on the right, you see this from Himachal. You see the brick gable. All right. There is some kind of RCC structure. I don't know whether it's RCC or what I would call pseudo RCC, but you see brick gable which doesn't have brick band, gable band, so it's vulnerable. Also, some of these are from Himachal. You find them along the road as you travel. In the villages, you have 3-4 story kind of very strange looking buildings, that mix of RCC and masonry. On the big pillars supporting 2 stories of RCC slabs. You can imagine what will happen if the earthquake strikes. In the lower left-hand picture, you see RCC slab, but there is no cranking. And on the right, you see an RCC column, but with ring without 135-degree bent hooks. So full of vulnerability. All right. Now, how do you identify vulnerability? See, typically the post-disaster situation provides fantastic indicators. When you see the building up close, immediately tell you that your masonry units are of poor quality or overall construction is of very poor quality. Completely separating like it's cut with a knife. It essentially tells you that wall-to-wall connections are not. It also gives you an idea of the general practice in a given area. You can go with the assumption that all right, here's a situation, roof has collapsed, all the maps, and why? Maybe from missing was not cut to the cable, number of reasons, all of them, all right, or one of them. Okay. Here's another situation where you have diagonal cracks, and it could be either because you have too many air openings or you have inadequate shear strength because of weak mortar. Another situation where your window opening is very close to the corner, so you have very little masonry there, and needless to say, it's not cracked. Okay, wall-to-wall connection, the whole full height crack. Obviously, wall-to-wall connection is poor, and probably the bands are also not there. Here you see the cable that has been damaged. So there is lack of connection between the cable masonry and the roof, maybe absence of band. Here is a classic situation which you find in the random rubble construction areas, whether it is Himachal, Uttarakhand, Latur, it can be Kutch, anywhere, where the wall is constructed poorly, the interlocking of stone of the 2 faces of the wall practically is non-existent, and the through stones are inadequate or totally absent. So under outplaying forces, the faces separate and they collapse, and the whole structure can ultimately come down. Or you also have a situation where the slab slides on top of the wall because it's not anchored to the wall. Very, very commonly done. All right. So based on, which is an excellent simple code, it's a prescriptive code which tells you what to do, how to check the vulnerability. What is required is to look at the building and start asking questions. Are there reinforced concrete bands or wooden bands at different levels? If there is gable wall, then is there a gable band? Is there a vertical reinforcement between your, at the junction of walls? Are the openings encased? If there is reinforcement around the openings like windows and doors, or is the number of openings within the limit or is exceeding the limit? Variety of things. Also, you can ask, is the roof anchored to the wall? Are there enough through stones? Number of things, right? So, if the wall is too long, if the interior wall and the exterior wall are connected, obviously the walls are going to be too long, all right? Unreinforced masonry walls. All right, so anyway, the number of vulnerabilities which you have to identify, you have to ask questions and find out. And based on IS 13935, for each of the vulnerability, you have remedy. All right, if random rubble walls are there without enough anchoring, enough through stones or interlocking, obviously you need to put in, you have to install what is called the cast in situ RC stitching element. All right. If the bands are not there, one or more, you have to install the belts. Okay. If you have the gable wall with timber lace gable wall, whether it has bracings or not, you have to look at that. If the corner reinforcement and the wall junction is not there, you have to put in the vertical splints, which is made of weld mesh. So anyway, I mean, if the roof diagonal, the roof has diagonal bracings or not, needless to say, will not be there. So, the variety of measures which are required to be done very quickly. Let's look at this. The first one is the cast in situ RC stitching element, which every one element you put into 0.8 square meter or 8 square feet of wall. It requires very careful. You have to make holes in the walls, and you see the section. You have to make a dumbbell shaped hole. You put some concrete, you put the S-shaped rod, you fill it up with concrete, cure it well, and this works beautifully. All right, a lot of testing has been done. We have also done a lot of testing, and it is very, very effective. Okay, so this is the first thing you would do is install the cast in situ stitching elements. Then, of course, if the bands are not there, then at various levels you'll have to install the weld mesh bands. So essentially, you have to draw the alignment of the wall. You remove the plaster. You rake the joints, clean the wall, and then you install the belt. Now, if the wall is of extra height, like you see in the left-hand picture, then needless to say, there'll be lintel band and there'll also be an eave band, and then also you see the gable. So all these are essentially belts which are installed on both the faces of the walls. Here in the left-hand picture, you see the inside view. On the right-hand picture, you see the outside view. All right, and this is a very, very just schematic detail of what is done. Weld mesh with some reinforcing bars depending on how much steel is required. You have to install it, and you have to make sure that it's installed very, very well. All right, because if it's not securely installed, when the earthquake strikes and the walls vibrate, they're going to separate. All right, and that whole retrofitting becomes useless. You need shear anchors every meter, secured properly in the wall, and then you attach your belt to it. In brick wall, nails work beautifully. You need long nails, about 6 inches long, and they're put in at about 30 centimeter spacing. All right. If the openings are not encased, then you need to put belts around the openings. And there are too many openings that, as is shown in the right-hand picture, you could block off some of the openings. All right. That's the easiest way to reduce that vulnerability. All right. Vertical reinforcement. Okay. So you need to, at wall-to-wall junction, you will have to install the weld mesh, what's called splint. There's also on the side of the openings for encasement, you install the splints. And if it's a 2-story structure, and if it's RCC slab, then you drill a hole. If it's a timber slab, then also you drill a hole. And then the belts, the splint at the upper and the lower story would have to be connected using steel bars. Just very, very common sense engineering you are doing. All right. Then coming to the roof. In roof, you need to do diagonal bracing so that you are able to create diaphragm action. See, the gables will be still provided they're anchored to the roof through the gable belt, and there are diagonal bracings in the roof. And, with these bracings, you are creating a diaphragm so that the shear gets transferred from the top of the gable to the eave level and then down to the ground. All right. And the diagonal bracings are made ideally in the hills using 10 gauge or 12 gauge GI wires, 3 to 5 strands. You really tighten them, using carpenter's hammer. You have to install them tight. And then once all the 4 or 3 strands are installed in a particular bracing, you take a steel rod so that you're creating pre-tension. All right. They have to be taut. Otherwise, they are not effective. All right. Well, if it's possible, you can also use timber, but then the end connections are complicated. All right. You need gusset plates, you need boards and all that. And this may not be possible in the rural areas. So wires are much easier. If you have masonry columns, they have to be encased. Without that, they're going to buckle in case of out-of-plane forces. And if you're encasing, then whatever elements are on the top of the roof, they also have to be anchored. In the bottom picture, you see the beam and column arrangement of timber, which I'm sure you find in Uttarakhand as well as Himachal. And in this cases, if there is any doubt between the joint of the beam and column, then to eliminate the sway of the whole frame, you use this knee braces. These are very, very effective and very easy to install. All right, to eliminate the lateral sway. Okay, let's look at some of the examples of retrofitting. These are in different parts of the country. This is in Gujarat, in Kutch, and this was done back in 2002 after the Kutch earthquake. Now, this is a small building or road and building department. It's a depot, and it's made of renderable masonry, and it's it had some damage, but you see all these holes are made for installing the stitching elements. Here you see the window that has been closed off. You see the lintel level belt. You see the cable belt. And the reinforcement inside is installed in here. In those days, instead of weld mesh, we used a lot of these steel rods. Weld mesh wasn't available that time in Kutch. Okay, times have changed slowly as the demand has gone up. All right, but all the basic elements. It was a small building, but very interesting to retrofit. Here is a school once again of renderable masonry in Kashmir. All right, near the LOC. And this was done, it was retrofitted after 2005 earthquake. The school was damaged, it had some cracks, the cracks had to be stitched. But then in addition, all the vertical reinforcement and the belts were added, all the openings and case all around. You see here's the installation of the belt in the upper picture. And in the veranda, we also install these this knee bracing, rather the K braces, so that the shear from the roof gets transferred down to the floor. Here are some more pictures being the renderable masonry. In each wall, stitching elements were added after making holes. Here is the vertical reinforcement being installed at the wall-to-wall junction. Interesting thing. This is the anchoring of the roof. Every 6 feet or so, there was a truss. So the truss had to be anchored very securely with the wall. So we had to improvise these brackets and things like that. See, typically in retrofitting, you have to do a lot of improvisation. What we call jugaad. All right, because the code will simply tell you anchor it. It doesn't tell you how to do it. All right, and you have to use engineering common sense and the other common sense to do all these solutions. Okay. Let me move. See, down below is a timber laced wall of renderable masonry. Okay, this is a 6-inch thick wall. This is commonly used in Kashmir in the hills, but it is timber laced, but commonly you find the bracings are not done properly, the joints are not done, so we had to retrofit those walls also. All right, now there is a building, a school building in Uttarakhand. Seismic zone 5. This was also building, again renderable masonry, and as you see in this end wall, large number of holes are there where the stitching was done, and you see the gable belt and the lintel level belt, the vertical reinforcement in the corner. What you see in this upper left hand picture, where all the wall surfaces are cleared and the belts are installed here. Same thing. And the bottom right hand picture, you see the completed school building retrofitted. All right, there's one more brick building, which I thought is a small building, not much bigger than a house. Okay, and this was like about 60-year-old building. Very, typical problems: large openings without reinforcement, missing belts, missing bands at lintel level, at eave level. The vertical reinforcement were missing. Encasement of openings was missing. We had the masonry columns, you name the vulnerability, it was that. And to make things worse, it had one large room where the slab was in bad shape because a tree had grown, a peepal tree had grown from this wall, and the roots of this tree had gone inside the slab, the full length and breadth of the slab. So we demolished the slab and recast it. Okay. Any other engineer would have demolished the whole building because of the bad slab. All right. But no, there was no need to demolish it. And we, we built the new slab with a new beam, and then the whole building was retrofitted. All right. Here's another school, once again of random double masonry. But this had clay tiles. All right. So again, the diaphragm was created in the roof, and otherwise various belts, vertical, horizontal, all the things were done. All right. Here is one, it's large building, but I thought it's worth sharing with you. It's a brick building. It's a hospital. And once again lacking every conceivable disaster resisting feature. Install the vertical roof, install in the roof here to create diaphragm, and then as you see here, the roof was anchored, so it anchored to so variety of things were done. All right, let me see. Now this building was brick masonry in cement wall. Now, as the earlier presentation today by Mr. Negi, he mentioned that as per code, you cannot build, random rubble masonry, or what we call the weaker masonry in mud mortar more than a story and a half. All right. But in the hills, we have 2.5-story buildings, isn't it? Whether it is Uttarakhand or Himachal or Nepal. Now, for the last 3 years, we've been working in Nepal. All right. And we evolved a system called containment reinforcement system. And this system has been, approved by Nepal. And that system is to build the new houses. And now in last 1 year, we have now used that system to retrofit, this 2.5-story buildings. Okay. So because otherwise the Nepal code also says that 1.5-story building is okay. Otherwise, you have to demolish the upper story. But if the upper story is demolished, what will you do? You don't have level ground in the hills. Okay. So this particular system involves installation of vertical splits at different places, and it has all the belts. And in addition, the containment reinforcement, as you will see in this picture, it has 4 mm GI wires. Okay, every 16 inches, and the wires are anchored to the wall with GI wire crosslinks. The holes are drilled in the wall, and your wires on both the faces, just as you have weld mesh on both the faces. Okay, and then in addition, you also have horizontal wires. See, the advantage of this system is that you are not using steel bars, so that you don't have to carry steel bars inside the hills, because logistically that's very difficult to be carrying steel bars. The bundles of wire, bundles of weld mesh are pretty easy to carry inside. The picture here is of the roof. You can see the diagonal bracings, all right, from ridge down to the eave wall, eave level, okay, on both sides, right? And from this is the gable wall here, so it's from one end to the other. This that. Also, there is a timber floor. So under the timber floor also are this diagonal bracing. All right. So this is just for sharing. This is not yet approved in India. We hope someday that it gets approved. All right. But in Nepal, I think in some ways Nepal I find more advanced in building technologies, and they are more open, because even today the Nepal code talks of timber bands. All right. As we don't talk. All right. See, when you bring the new ideas, retrofitting is a new idea, and you have to bring faith in this thing. You have to bring confidence. And one of the things we have learned from Professor Arya is to use shop table testing. So in Latur, back in 1994-95, we had created a shop table that we had learned from Professor Arya. We did 4 tests in Latur. Later on, we did 4 tests in Kutch. And now we are building a shop table in Nepal, in Kathmandu. Okay, so here you see 2 houses. What you see here, this particular house on the lower left-hand corner is retrofitted. The one house on the right is not. Okay. Giving several shocks, the unretrofitted house has collapsed. Okay. So this gives you, I mean, right in front of you, you can see a very crude earthquake happening, and you can see how the house gets damaged and it collapses. Right. So it's a build confidence of the engineers as well as now the scenario. See what has happened in last 25-30 years. We have seen that very little retrofitting has happened as part of pre-disaster action. Retrofitting is really like your inoculation or vaccine. You do that before the disaster strikes. All right. So what has happened is that in disaster after disaster, we have seen that the buildings have been demolished rather than getting retrofitted. Now this is happening. This has happened because few authorities are promoting retrofitting as the viable option for long-term security against earthquake. And there are reasons for this. All right. And also people are ignorant and they are not readily accepting retrofitting an option that can be adopted. And finally, contractors and masons in the rural areas are ignorant about retrofitting. See, in the rural areas, contractors and the masons, they are everything. They are architects, engineers, and builders. If they have confidence, they can build confidence of the people. All right. Now, the principal cause, the number one cause of this sad scenario is that most engineers who are the principal actors are ignorant about retrofitting. They don't have any confidence in it, and they find it, often they find it economically unattractive. All right. And hence they don't recommend. What we have seen also year after year, the building professionals, for them it is easier to start on a clean slate rather than going, worrying about the existing building. So they want to go for reconstruction. That's what they will recommend to their client. Now in rural areas, majority of existing buildings, even today, all right, understanding of masonry. All we are taught is reinforced concrete, isn't it? I mean, I went to IIT 55 years back. Okay, I graduated from IIT in 1970, and all I knew was steel structures and RCC. So obviously, when I come out in the field, I'll say, "Oh, masonry is no good. Get rid of it." All right, that's what is happening. Okay, and the problem with RC frame building, whether they are in urban areas or rural areas, they're complicated to analyze. And as they're time consuming and hence expensive. So that's the first major hurdle for RC buildings. People don't want to pay that much money. Finally, in short, the delivery system for retrofitting does not exist today in India. Okay, now just the state of know-how and guidelines available. As I mentioned earlier, IS 13935 or BIS is there, very much there. There's a wealth of information in there. Now, based on that IS code and based on the work that we have done in last 2.5 decades, we have made a number of guidebooks. Okay, so back in Latur in 1994-95, this is a time when Amir Ali ji you were still student at that time. We had met him there in Latur. And so in Latur, we started the retrofitting and we made the first guidebook on retrofitting. First, it was made in Marathi, and then it was done in English. Later on in 2007, after the 2005 Kashmir earthquake, we made a retrofitting manual for Kashmir. Then in 2010, we made retrofitting manual for Himachal Pradesh and Uttarakhand, and this was done for the government of India. And in last 1.5 years in Nepal, using the CR technology, we have made the retrofitting manuals for Nepal. This has been based on actual work carried out. All right. So it's not just academic. All right. Now, what is important though, you may have all the information, but you have to take it to people. All right. See, today in Nepal, the problem we are facing, the government of Nepal has approved our technology, but nobody is going to use it unless we take it to people. The government has no agenda to take the technology. Someone else has to do it. Okay. So we have been doing that. All right. So you need to conduct meetings, you need to conduct exhibitions, you need to conduct video shows. You know, in this picture of in the middle of the lower right, side, street plays. You know, street plays are another fantastic medium to communicate with people. All right. So that's this one thing. Okay, I already the shop test. So that's another thing that requires to be done. You know, pretty soon in Kathmandu we will be conducting one more shop test. All right. So finally, I think I have to think of saving existing building rather than demolition. See, today our mindset is remove the existing. Existing is no good, it is out of fashion, it's backwards, it's outdated, but that is not the case with majority of building. It's our knowledge which is outdated. All right. You have to aim for better. If best is the best, okay, in your eyes, but it's not feasible. So let's aim for better, which is retrofit. Okay. Best is the enemy of better, which is a very, very common proverb. And every retrofitting measure will help reduce vulnerability. Mind you, I mean, there are 7 or 8 things to be done, but let's not worry about doing everything. What can we do? All right. So go for incremental approach. So this is often the case, whether it is the government agency or whether it is your home. You may not have enough money. All right. So just go with an incremental approach. Let's retrofit the ground floor first. Let's retrofit the next upper floor first. Or let's just install the belts first. So there are some logical way of doing it. But we need to do something now. If you do something now, you'll do something later. All right. So then you have to believe in it and you have to push it. Thank you.
Thank you so much, Rajendra Bhai. It's a wonderful presentation as ever. So, how are you placed for a few questions?
Sure, no problem. In 5 minutes.
Okay. Yeah. So, Garima ji, do you have some questions to ask about Himachal Pradesh and retrofitting programs in Himachal Pradesh? Garima, are you there?
Yes, sir,
Sir,
I'm there. And also there is this question raised in the chat box that where can we get the retrofitting guidance from? So, sir, if you could elaborate on that aspect.
Well, I mean, see, the retrofitting guidance, and I'm talking about masonry buildings. Okay, I'm not talking about RCC building. I think the thing is that you need, I mean, to begin, you need retrofitting training. Really, that's the only way to start. All right. I mean, one can get our guidebooks and start with that. But to me, we have conducted large number of trainings. In Kutch, for example, we had trained 1,200 government engineers. All right. In Latur, we had trained something like 600 government engineers because that's a good beginning. You see the thing happening in front of you, and that's where seeing is believing. So I think that's the best way, that if on-site training coupled with classroom training takes place in a particular region, addressing the local building systems, then that's the best way to go. And then of course IS 13935 is there, our guidebooks are there, and then it's up to you. I think the main thing also, I'll tell you, Latur back in 1994, see, on the second day of the earthquake, third day of the earthquake, when we arrived at the affected area, and immediately what came to our mind was that in some villages there was total destruction, but then in other villages there was absolutely no destruction at all, and they were not far from the epicenter. So we were wondering that if tomorrow another earthquake strikes with slightly different epicenter, also get destroyed. So that is what got us, that we spent some time with and we learned, and then I was actually learning while doing type of thing and using common sense and engineering common sense. That's how we did it in Latur. Professor Arya was sitting about 1,000 kilometers, and those days, of course, we did not have mobile phones and WhatsApp that, but still we were able to do it. And there was a lot of learning while doing that thing. So if somebody is not doing it, then that's one way to go and do it. All right. And our manuals have a lot of information because it's based on totally practical work that we have done.
Sir, the participant wants to really know ki where from where they do can get your manuals, the guidelines which you have already showed.
See, there are. I'll tell you one thing. One, this manual that I showed in the presentation is from BMTPC, Building Materials and Technology Promotion Council, right? Government of India. It's in the Ministry of Urban Development or Ministry of Housing and Urban Poverty Alleviation. That's what it's called now, UPA. So maybe they should still have prints with them. And secondly, from our website, you can download them. Of course, the downloaded edition may not be that great, but still it'll be there. And also, see, we made for UNDP, we had made a manual back in 2008, which also has a good coverage on retrofitting. It covers the masonry new construction as well as retrofitting. So that is another reference which may be available with the UNDP. I think this is basically what's there.
No, but my personal opinion is that there is a lot of literature available. You just need to be keen to find that literature. Lot of sources and resources are available around. So all the participants, whosoever is interested, write to NIDM, write to Rajan Bhai, write to so many agencies. Lot of work has already been done. The advantage with Rajan Bhai's presence is that he is one of the pioneers who has evolved the retrofitting techniques by doing and by learning. So a lot of knowledge has already gone through his manuals into this profession of retrofitting. The only setback, in my opinion, is that not many people are keen to take retrofitting thing as a challenge. And as he rightly mentioned, that everyone needs a clean slate. Nobody wants to experiment and learn the art of spending time and taking those pains. So that is the advantage of listening to Rajendra Bhai, that इन्होंने जो काम किया है ना, वो सारा इनके अपने हाथों का है, और जो इनके मैनुअल्स हैं उसमें सारा निचोड़ जो इनके एक्सपीरियंस का है, उस रीजन का, उस एरिया का, वो उसमें नजर आता है. सो आप में सिर्फ ख्वाहिश होनी चाहिए. यू जस्ट वांट टू लर्न द आर्ट एंड थिंग्स कैन बी सॉर्टेड आउट. सो लॉट ऑफ लिटरेचर इज अराउंड, नो डाउट अबाउट दैट. और पहले जो इंजीनियर्स का बता रहे थे सब, तो वही है कि कोई चैलेंज लेने को तैयार नहीं है और एक्सपेरिमेंट करने को तो बिल्कुल ही तैयार नहीं है. एंड राजेंद्र भाई तो कब से कर रहे हैं, वो 30 साल हो गए उनको ये सब करते करते, और that is the advantage with Rajesh bhai.
Can I add one thing? See, I mean, I personally feel that you need some inner thing to move you. Now, yes. I mean, I'm an environmentalist at heart, and I came to realize this 25 years back, that environmentally retrofitting is better, because definitely, I mean, we are talking about carbon footprint right now. Those days we were talking about what is it, the embodied energy. All right, and if you have to demolish a structure and rebuild, the amount of energy that's going to go into that is going to be enormous. Compared to that retrofitting, the embodied energy will be much less. So that, and the economics, how people can make themselves safer, I think all these things are there. And so if you believe in these things, then you will do it. Otherwise, you're not going to take trouble to do it. Yeah. It's as simple as that. Unless there is a reward, okay, from somewhere, then people may go for it.
So any more question, Yogita?
No sir, no such major questions.
Because Rajendra Bhai is also hard pressed for time today. So Rajendra Bhai, sorry, we are not posing more questions, but maybe another session with you shortly. So let's keep our questions with us. And maybe next time we will explore more possibilities of having a discussion, detailed discussion with you, and benefiting the participants for with your vast knowledge and expertise. So with this, we thank Ryan Bhai on behalf of NIDM, on behalf of HPSDMA, and the entire team of NIDM and HPSDMA for sparing that much of time. So it's wonderful to have you every time. So it's a pleasure to listen you always like that. So formal vote of thanks, Garima or Yogita.
All right. Good. Bye-bye.
Thank you so much,
I
sir.
will keep it very brief, and thank you so much, Dr. Desai. It has been wonderful learning from you about retrofitting, and we intend to write to you to gain more from your experience and vast expertise. Thank you very much, sir. Thank you, Anand sir.
And as sir said, the reward is needed. If the reward is needed, the reward will be the safety of us, safety of our own people, and safety of the community. So with that, we thank sir for joining with us. We thank all the other speakers for joining with us, like Dr. Girish Joshi sir and SK Negi sir. And for the participants, again, for the day 3 of the technical sessions of the training program, we will have the same link. Those who had some issues with the feedback forms, the feedback form for day 2 will also be shared on day 3. If somebody has any kind of issues, they may write in the chat box, and we will answer that query as well. With that, I think we can close for the session, ma'am. Thanks, sir.
Yes, but with the request to all the participants, try to be on time tomorrow as well, because tomorrow is the last day, and we have to have discussions as well. So try to be on time and complete your feedback thing, because without in absence of that, it will be very difficult for us to issue a certificate. So for certification purpose, it is a mandatory requirement to complete that feedback form. With this, we just conclude and thank the entire team, including Yogita, Garima ji, and all the participants, and 3 speakers today. Slightly hectic, but in 3 days, you can't complete the entire syllabus of disaster safe housing in rural areas. Still, there are many topics which should have been included, but we omitted. But maybe next time, another part of this same program, slightly lengthier, we may explore more possibilities of including more sessions and more technical talks. With this, we just conclude for today's thing. And thank you all for sparing time and being with us. It was a good session. I enjoyed thoroughly, and I hope all of us have enjoyed.